Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they are live, and a link in the info box once the video has rendered. But most importantly, if you would like to join the debate, simply mute the page you are currently watching, then click the link in the info box to join the discussion and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number one, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show, as sharing the show increases the live audience, and this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you are new to the channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by Spurs Chemo, Sleeping Warrior, and Ranty Rant, or Ranty. How are you all doing, gentlemen? Good to have you here.
Good morning. Good morning. Good to see you all.
Morning. Sleeping Warrior gone to get a brew?
No, I was here. Just I had myself on mute accidentally. I'm good.
Good stuff. So, back from St. Bees, all rested. Spurs, haven't spoken to you since.
No, just been listening to the backlash. It's been interesting. Just to see where we're going to go from there now.
I saw Imrich's chat, Imrich's video last night, basically saying that we were dishonest. Have you seen that, Nath?
Nah, I don't watch Imrich.
I saw a little bit of it.
Basically, what he's saying is that he's not happy with the length of the tape, and he's not happy with the angle that you took on Dioptra, because the angle of the tape, the length of the tape, I can't remember what his reason was, but he wasn't satisfied that the length of the tape was at the time that the picture was taken. The video was taken, and it wasn't down to the floor because you couldn't see that it was down to the floor. And the Dioptra photo that was taken, when you were at the bottom looking up, he said that you weren't even in the same place. And I was like, right, so you're basically calling Nathan a blatant liar then, okay?
That's interesting. So I got a comment from Mark saying, why isn't it measured the highest point? Because in the foreground, I'm right up against the cliff when I did that Dioptra angle, literally right up against it. So as I tip the camera up, there's a piece of land that's maybe 10 or 12 feet high that's right next to me. And because I'm right up to the cliff, it's in the near foreground right next to me. Because I'm right next to it, obviously. So Mark's like, why didn't you measure that? And I'm like, because it's right next to me on the right-hand side. It's in the near foreground. Anyway.
Yeah. That's because of the coastal erosion caused by the sea when it bashes up against the rock. We see that same effect where Miles done his video, and we see that same drop there. So that's how we know that coastal erosion is really a thing, and it's also how we know that it's prevalent in both positions. There is a steeper drop right at the bottom. That's because that's where the land drops away first. That's the process known as coastal erosion. And if you take a picture of that and get the angle, people obviously say, you didn't get to the top of the cliff, you moron. So obviously you have to compromise. However, one of the criticisms that Imrich said was that we didn't give them a fair hypotenuse or a fair angle. And I agree with Rick. We didn't give a fair hypotenuse and we didn't give a fair angle. And let the records show that that was because of me. Yesterday, or the day before, when we did the Miles Davis lie, basically what happened was the rumpus decided that my vertical wasn't good enough, and he constituted a substitute horizon and called it a, quote, deduced horizon, which I'm going to refer to as a fraudulent horizon from this point on, basically because he didn't like the 20 degrees. So he didn't like the 20 degrees, so he made it into a 30-degree angle, called it a deduced horizon, and then you ballers didn't even challenge it, question it, or you just accepted it. So I said to Nath, right, how do we stop that from happening this time? Because we did the rumpus one intentionally first to see what the criticisms would be, because the top value was really the one that we wanted to go for, because it was where the composite came from. It's where Mackled Lighthouse arguments all result from. And the issue was, well, what do we do to stop that from happening? Because I don't want rumpus faking my evidence. I want rumpus to accept the evidence. And yeah, okay, you can have a bit of an adjustment if it's not absolutely, in your opinion, rumpus. true 90 degrees. But I don't expect you to manipulate the evidence, change it, and then for it all to be accepted by the ballers. No, that's literally...
Anthony, look, anything you've done and Nathan's done is never going to be good enough. You've thrown a tape down literally from the top to the bottom. It's one tape. You've got one full measurement. It's undeniable, and it's still not good enough for them, right?
Okay.
But yeah, they will jump all over Miles Davis with his composite tape measure, i.e., 2 particular measurements held together by sticks and a rock, and they will claim that that is accurate, whereas your one full tape from top to bottom isn't good enough.
Well,
it's never going to change. It's always going to be that way. You could never please them. You could literally do it. You could have a drone footage of you doing it, and it still wouldn't be good enough.
Well, it was decided that we wouldn't give them a hypotenuse for them to argue over, and we wouldn't give them a measured angle because the rumpus will change it. It's not acceptable. So we thought, well, what is the best way to do it? So Nathan just said, okay.
I was just going to say then, so did you see the little video I edited together from your footage from a couple of weeks ago? Have you seen that yet?
Which one is it?
Maybe not. So if you go to Skype and just check it out. I've uploaded this to YouTube yesterday, but after I did it, it's not my footage, it's your footage. I've edited together your footage from a couple of weeks ago that I said, look, just don't release this. But now that, you know, we've got the highest point possible done, even though the measurements that you guys made a couple of weeks ago on that middle elevation is, what's the word? It's inconclusive, but I'm happy to release it if you're happy for me to release it. So I just need you to check it. Ranty's checked it and said, yeah, it's fine, just put it out there.
Is it the one that's IMG 3272?
I've no idea. I'm in the middle of running the show, so I can't check. But I don't know. Probably. It's about 3 or 4 messages up from the last message I sent you on Skype. But if you can duck out for a couple of minutes, it's literally 60 seconds long. Just have a check of that. But I think people will probably appreciate why I was like, I think that'll just cause rows. But now, I don't care. You know, the composite image, as far as I'm concerned, is pegged. I've had Chris yesterday doing some extrapolations on tide data to give us an actual mean sea level, so we can calculate exactly what the mean sea level is. So based on that, we can then start plussing on or adding on or taking off various different tide measurements to the actual observation point. So, you know, that's something I want to do with Chris, because it's not me that's done these extrapolations. So, again, if people are going to be critical of them, which of course they will, I want them to actually see the measurements, the calculations being done by Chris, so they can see how we've come to the figures that we've come to.
Yeah, I think when me and Anthony went and we did the same thing that you guys did, which was throw the tape off the end, get a hypotenuse, get the angle, and we figured it out to about 79 feet to the top of the highest point. You got an 81-foot measurement, so you know we're happy to say what 80 feet is a fair estimate for that top of the hill.
I'm happy to say 81 to high tide, but that's high tide.
That's so, the high tide, correct?
It needs some.
Well, Anthony's video was clearly done lower than that. I think, if I remember rightly, it's a while ago now since I've looked at the actual data on the day, but I believe the tide was about 3.5 meters when he did the actual observation. Now, high tide in that location is about 8.5 meters. So we've got about 5 meters there that we can add on top of the hill height, which is about 16 feet that we can add on top of the 81 foot. So that takes us to about 97 feet on the actual day that he did the observation.
No, it's going to be more than that.
Actual water
I already know, sorry Ranty to interrupt you, I already know from doing the extrapolations with Chris yesterday that it's going to be higher than that, just to let you know.
All right, okay, fair enough. What do you think that it would be then?
I can tell you exactly. Give me a second. I don't want to do this. I'm stealing Chris's thunder, so I want Chris to go through it. I don't want people to hear my figure and start criticising it, and then Chris go and explain how we've got the figure. I just want Chris to say, this is the figure that I've got, this is how I've come to it, based on the measurements that we've done. I mean, what we've released is one of the measurements that we did on the day. You know, we did several. We measured the lower hill, we measured the upper hill. We went back the following day and tried to get another measurement, which we abandoned. You know, there's lots of work that we did to get lots of measurements. The week before, you got a measurement. The week before that, you got a measurement. So we've got lots and lots and lots of measurements. You know, Miles Davis has got a measurement, and all of this information is useful.
No. Miles Davis has got a calculation.
It doesn't matter. It's just more. It doesn't matter if it's sketchy. I know what you're saying, but it doesn't matter. It's just an extra bit of data, regardless of how sketchy it is, and I can take all of it into account when giving the height. At this point, I know you guys want it to be as low as possible, and I know the ballers want it to be as high as possible. I don't really care either way. And from what was this bit, I will divulge. So what Chris was explaining to me yesterday is the only bit that's really relevant is the differential. So on the diopter app, you can see that there's a little arrow that says 74 up. Now, what that's actually referencing is WGS84, the geoid, right? And it's giving you a sea level reference based on that geoid. Now, that's a fixed reference plane. So that particular point will be the same on the other side of the Isle of Man if I was to be in a boat looking up with the diopter app with a guy at the base of Morgold Lighthouse with a tape measure. In other words, if we replicated the measurement, what the number would be, as long as I use the exact same phone and the exact same app, it will give us a reference for the WGS84 at the base of the Isle of Man. So let's say, for the sake of argument, the tide was different by 10 feet, just for the sake of argument. That number would be plus or minus 10 feet, that datum reference. But that tells you, once you've added on or minused off or kept it the same, if it's exactly the same, that gives you a reference to the sea. And all you're trying to get is the differential between the two locations, i.e. the lighthouse and the hill at St. Bees. So the way Chris explained it to me was as follows. If you imagine that you had a perfectly level concrete bridge from your position at St. Bees all the way across to Morgold Lighthouse, yeah? It doesn't matter that the bridge is at 100 feet above sea level, 1,000 feet at sea level. It doesn't matter, because the difference between the height of your position and the position of the lighthouse base will be a constant differential. It doesn't matter where the sea is underneath that. So in other words, obviously we don't have a concrete bridge, we only have the sea and reference points that are calibrated in these diopter apps. And they are sophisticated. I mean, the app I bought, yeah, it was cheap, it was about £6. But, you know, the blurb was all about how it was used by surveyors and how well it's calibrated and how well it's referenced to these datum points. So if it's good enough for surveyors, it's good enough for me. Chris has backed that up and said, look, so long as you've got that number, you can then cross-reference how high you are on a plane versus the two. And that's really what we want. How high or low are you by comparison to the actual lighthouse? Doesn't matter where the sea is. The lighthouse isn't moving. It's not going up and down. It's not, you know, it's not Skunk Bay. It's not coming in and out and going up and down and higher and lower with the refraction. That's not what's occurring. It stays in the same exact position. So therefore, what we need to know is what's the difference in height between you at the coast and the lighthouse. And the sea level in that respect is completely irrelevant. What is relevant is the accuracy. So all I'm interested in is getting it accurate. Because when I go to the other side, if it's been fudged up by globers or fudged down by flat earthers, obviously I'm a flat earther, I'm going to disclaim that now. I am not biased, I am not neutral, I'm just trying to be neutral because I want accurate data in this regard. And I'm sure I've said this to you, Ranty. After the fact, I looked at it and went, yeah, I could have manipulated this down. And then you confirmed that by saying, well, we got a lower measurement. Hello, Black Circle, how you doing? Can you hear us? Hello.
Hello.
Good to have you. What can we do you for?
Oh, nothing much. I'm just here to listen. So pretty much I'm a globe earther. And yeah, in the comments I get a lot of shit for it in the comments recently. And I'm not here to argue. I just want to explain what made you believe, like what concrete evidence made you believe that the earth was flat.
I think the best way to deal with that is to come back to it later. We're midway through a conversation at this point, and although it's great that you're in, if we could just finish off this point and then we'll come back to you, that would be great.
Sounds great, yeah. I'm sorry.
No worries. Thanks very much. Nathan, you going to carry on?
Yeah, my Hangout's just really slow to react. I pressed the mouse on his volume about 1,000,000 times, so if I'm a bit slow doing things, it's just the Hangout's a bit slow to react. My apologies. But I've turned your volume up, mate, so once we come back to you, I will give you an answer what makes me think it's flat. But I was pretty much done, actually. That's basically what we need. We need the differential between the two locations, and in that regard, the sea level is irrelevant. It doesn't matter, but it's being used to get that differential. So the accuracy is all that matters. So yeah, people will come and argue with me that I'm out by this and out by that, and I don't care. You know, argue with me all you like. If it's to your satisfaction that it's higher, then great. You know, add a few feet on. I don't care. You know, I'm only interested in getting the accurate data. So you know, I'm not really doing it to appease you guys or the Globers or anybody other than myself and Chris, and that's really it. So well, I don't care what anyone criticises it for.
I just want to correct one thing that you said there, though. You said that I know you Globers are going to try and play it up, and you flat earthers want to play it down. To be honest with you, I'm not really interested in what the value is, because no matter what value, we'd done the maths and worked out what value we would need to bring back the tippy tops of Mackle Lighthouse, and we're not anywhere near it. No matter what value we get, that lighthouse doesn't come back. So for me, it's not actually about trying to downplay it. For me, it's just trying to get something that the ballers will accept without falsifying, so that we can know and accept what the actual elevation is. Because to be honest, I was pissed off when the Rumpus changed my evidence to suit his premise, because that's dishonest. Now, the ballers didn't challenge him on it whatsoever. They just accepted that this deduced horizon would be an acceptable excuse, reason, or whatever. And that's nonsense. The reality is this. It isn't as tall as what Google Earth claims it is, even if you include that mile plus or minus 30 meters worth of nonsense inaccuracy. It's relatively accurate. Yeah, it's not absolutely accurate, but it's not wildly inaccurate. So anybody like Sean Hufford that quotes me as saying that we think that the elevations on Google are accurate, no, we're just saying that they're not wildly inaccurate, and there's no evidence to support them being the case in this case. I think it was 7 meters out. Is that what it was, Nath?
Yeah, something like that. I can't remember like looking exactly, but
it was. I mean, it was less than 10. So the claim that the elevation is out by plus or minus 30 meters is nonsense. It might be at the top of Mount Everest, but it certainly isn't the case here. So Sean Hufford, so misrepresenting me again. We are not saying that Google Earth is accurate. What we are saying is there is no evidence that it is wildly inaccurate. I know Sean can't cite me properly ever, but at least get it right, Sean. You're supposed to be quoting what the claim is. Get it right. We're not saying that Google Earth is accurate. We're just saying it's not wildly inaccurate.
Yeah, I think we've laboured that point plenty. I mean, I want to answer this guy's question. So he said, what to me proves, as I don't know how he phrased it now, I can't remember to paraphrase what the guy said. Maybe you can ask your question again.
I just stated what concrete evidence made you believe that the Earth was flat? Like, what started this whole thing is what I'm trying to say.
Okay. I mean, at this stage, the thing I would give you as evidence that the Earth is flat is a comparison between the two models. So you have a couple of choices. You can either believe that the Earth is a sphere, or you can believe that the Earth is flat. What evidence have you got for either? And the Isle of Man would be that evidence. So you have a situation where you have a lighthouse on the other side of a 31-mile stretch of water that is physically impossible to see on a sphere 24,900 miles in circumference. It simply isn't there. There is a 165-foot wall between you and that point of observation, that lighthouse. You can't see through walls, so you can't see that lighthouse. Also, it's 650 feet below you on the other side of a curve. Obviously, the Earth is a sphere. So the way it stacks up is you can't see it. So therefore, in that particular model, you have to have a band-aid theory applied, which is refraction, to, quote, bring the lighthouse back, or to put it another way, let you see it where it cannot be seen. So that is the model that you guys have.
Oh,
bear with me, Hi, Lottie, I will introduce you. How are you doing? The model we have...
Hi, Nathan.
Hello. The model we have demonstrates it very simplistically with straight lines of sight like surveyors use. So we measure angles and then take a direct line of sight to any item on the model, and then you can measure its distance, its elevation. You can measure it and get an accurate result. So we have a flat Earth model of this observation that works, and we have a globe Earth model that doesn't work. So the evidence would be the flat Earth model that works where the globe does not. That would be my evidence to present you.
Mine, if I can respond.
Very
Mine,
interesting. Yeah,
Well-
very interesting per se. I could see why it would made you believe that the Earth was flat. Have you ever thought about?
Well, hold
like,
on, Black Circle. Before you get onto that, could you explain what he just said and explain how, if that question could be answered, you could turn any flat earther into a ball earther kind of immediately if you explained this wall. Yeah, you're about to jump onto something else completely different. If you'd just said, well, oh, this is easy. Of course, this is explainable. Well, this, and this is why. But you've just dismissed what was said and just said, well, that
I
doesn't
didn't
explain.
completely dismiss it. I was just listening to it, just literally taking it wholehearted, just listening to what he's saying. I wasn't dismissing it.
Okay,
Oh,
so address.
All right. So pretty much what he's explaining is all right. All right. So that was a lot to take in, first of all, because that was like literally 3 minutes of talking.
No, I did think that. I did think you probably didn't grasp the whole concept. So, the whole concept is that there's a wall. So just imagine a wall between you and an object. So how do you explain that wall?
How do I explain that wall? Like so you're explaining vanishing point is what you're explaining?
No.
opacity.
Let me just try once more time for
Try
him.
to keep it very simple. Between you, observer, wall, and object.
Mm-hmm.
Yeah. How do you explain that wall?
What do you mean how I explain that wall?
How do you see over a wall?
How do you see over a wall? The more you elevate up, depending on how the height of the wall is.
So I'll explain it once more for you, Mr. Circle. So we have a wall between us and the lighthouse we see in a picture. So on your model, there's a wall blocking your view. On our model, there is no wall blocking your view. So in our model, we just see it, and that's perfectly acceptable. There's no explanation required. We see it. In your model, you can't see it. Do you get that? Hey, Kanye West, how you doing?
Yeah, I get.
And you Lottie, not Kanye.
Yeah.
Oh
don't like
man, what was that?
Terrible, Lottie.
But yeah, I understand that.
No, but again, Black Circle, you could change many people's minds if that question was addressed. You would just say, look, this wall is not a wall, or you give an explanation how you see it. You, observer, wall, object, something in between. Yes? On your model, there should be a wall. In reality, there is no wall. So how do we resolve that?
Well, like completely honest, I'm not sure because I partly agree with you on that. But that's a very complicated subject. Well, the best I would explain it with the wall is oh fuck. All right. Yeah, I have to think about this.
And you see, it's not a trick. It's not a competition. It's a very simple, logical thing. You either have to accept something is really there or something is not there. Yes. So
Yeah.
if you were able just to explain to all the flat earthers, look, this is what happens, this is how it works, this is the numbers, you've got it all wrong. But like you've just struggled right now. This is people can't explain. In reality, we see objects, but on your model, your Bohr model, there's a big wall. What is this wall?
Explain it again, like a wall. So you're explaining a lighthouse, a wall, and then you as a person. And
No problem. Can I have another go? I'll have one more go.
So my first initial question is, how far is the wall from the lighthouse, and how far is the lighthouse from the wall?
No problem. I'll explain. Let me just try
go on,
Spurs.
go on.
But let me just have a quick go, Spurs. So I'll give it you in small scale first, right? So
Yeah.
you know what your front door looks like, yeah?
Yep.
Now imagine you've got your front door and all of the front wall of your house, but you don't have a roof, so it's like an open house, yeah? You come outside.
How far from the house? First of all,
just let me give it you in small scale, and then I'll give it you in big.
In front of the door, like 10 feet away from the door, 30 feet from the door. Like
You are 6 feet tall. The door is 8 feet tall. Okay, so the door is taller than you. You come outside your house. You shut your door behind you. You look at your door.
All right.
Can you see the stuff on the other side of the door? Yes or no?
Nope, you can't.
Right. The lighthouse is on the other side of a 165-foot wall of earth in your model. There is a wall akin to your front door that you can't see through. That wall is not something that you can see through, and the lighthouse is on the other side of it. Not only is it on the other side of it, it's 650 feet below your feet. But ultimately speaking, what you are looking at is a wall that blocks your view of the lighthouse, like your door blocks your view of the stuff on the other side of it.
All right, now I understand your analogy, but yeah, I think there's a little bit of a little bit of invalid in between of all that. So first of all, so take the Earth. How big is the Earth around? Like I would say like in circumference like 683 million kilometers.
It's a conference like
Hey
600
Lottie, how you doing?
Explain
Hello,
this. So
my
since we're
mic
on
okay,
a plane
Nathan?
that
Can you
big,
give me a minute to sort it out, please?
You sound
and with
Hey,
awful.
some
Lottie.
flat earthers in which they agree, like the circumference of the Earth is equivalent to like a globus, and distances across from a flat Earth are relative to a globe Earth. So let's take that for example. And pretty much you're standing in front of this, gigantic plane, and literally it's massive. So you have to take also that into consideration, and you also have to take vantage point into consideration, because the bottom disappears first, obviously in vanishing point.
You're right.
So
You're right. You're right, Black Circle, and that's what we've done. We've taken observations from 2 points on Earth, and we've tested to see if your model is correct. So we looked at your before we actually went to the observation points, we checked the numbers of your model. So we were told it's 24,000 miles all the way around, and you can only see objects at yay height so far. So we've done that. So you're thinking that, oh, well, you need to know the height, you need to know the place. Yeah, that's been done. We've checked all those things out. We've tested it. And now we're asking you, yes, about this wall that is supposed to be between the observer and the object. Yeah, so what you're talking about, we've done. We've checked. We checked your globe first. We didn't just go out there into the open and say, right, we're going to just look at see what we can find. We said, no,
yeah,
let's look at your model. Let's look at the numbers first. And then it's called testing the globe. I'm sure you've heard of testing the globe. So you can do it. Anyone can do it. If you're given a value and they tell you you can't see object B, well, it's up to you whether you believe it or not. You would have to go out and test it. Yeah. So we've done that. We've tested if you can see the object. So now we don't need to discuss about, oh, well, if you were higher, if you were lower. We've been through that. Yeah. So we're at the point now of the explanation. We're asking you, why is there a wall in your model, but in reality, there is no wall in what we have observed, not just anywhere on Earth, just in what we have observed. Why is there a wall between the observation and the observer?
Well, there's three different. Well, if you're gonna look at it this way, you realize there's three different types of horizons, right? Astronomical, visible, and true horizon.
Yeah, absolutely. Like I just said before I began, I said we checked all the parameters of what the globe requires. So all of what you're saying was pre-checked. We checked all these things: horizon, altitude, levels, heights. All of what you're saying has been checked.
Mm-hmm.
Yeah.
All right. Yeah. Keep going.
Yeah. So how do you explain that, this wall?
Well, the simplest I can explain it is that pretty much vanishing point and pretty much of the distance of where you're from. Because obviously from your house, if you exit your house and you pretty much look at your 8-foot door and you can't see your roof and you can't see what's the lighthouse 30 feet, how much did you say was it under you? I didn't quite get that. The lighthouse was 300 feet under you.
If you want to take the absolute maximum that you can possibly be in height, you could say 115 feet in the air. Right, that's the number that we got on the tape measure. So forget any extrapolation whatsoever. Just say that you're at 115 feet in the air. The wall
All right.
is 165 feet high.
All right.
So you ain't seeing through it. Yeah?
Uh-huh.
Right. So that's what Spurs is asking. Why do we not see any wall blocking our view of the lighthouse? Why isn't there a door in the way? Why is it that we've gone through a front door and can still see the stuff on the other side of it? Why is that?
Well, to put it in basic words, well,
Mm-hmm.
it's quite a complicated subject because there's a lot of mathematics going into this, explaining like curvature, different atmospheric refraction, obviously, and pretty much objects above the horizon. But like what I can give with my solid conclusion, mind you, I'm still in like college, and I'm not like an extreme like scientist where I could like name you every like little bit of information. But what I can tell you is that that's there's a little bit of a sketch, and I can see where it's messing you up. But
So hold on, Black Circle. So this would bring us back to the original question: what makes us believe the Earth is flat? Because we've just given an example that there should be a door, wall, bulge, whatever you want to call it,
Hold on.
between
Hey, Alex. How you
observer.
doing?
Hello.
Can you hear us?
It's me. Don't snipe me.
Like, so we go back to the original question of what makes people believe, and this is it. This is the very thing. So I would have to say to you, what would make you believe you're on a ball if in reality there is no bulge, wall, or door, or whatever you want to call it, something blocking between you and the object? Why would you then, from that moment, believe you're still on a ball?
what made me believe that I was on a ball?
No. Not what made you believe. We were all in the same boat. We all believed in the ball for the same thing because we were indoctrinated. But from this moment now, where we can give you, test results, observations of things that you shouldn't see, what would make you think you are still on a ball from this moment forward?
Oh, well, what made me believe that I'm still on a ball? Well, first of all, like
today, we just asked you. Yeah, so we asked you, how do you explain there's no wall between observer and what we observe? You said, I don't know. I can't explain that. I don't understand it. It's gone over my head. You're saying that there should be a wall, but there's not. So from that moment, why do you still believe you're on a spinning ball?
Well, from that moment, well, it's kind of hard to explain why I would think I'm still on a ball.
We have time. I'm interested. We have time.
Well, it's also depending on like the time of day, to be exact. Also, like I would also put that into perspective. Well, obviously, like from the sun, you could grab trajectories from the shadow, like of the sun in which it casts, which Aristophanes, yes, that's his name. Yeah, he like with two poles on the ground of the Earth. He calculated the Earth's circumference.
How are you doing, Lottie? So, I'm trying to cut this relatively short because it seems like.
Oh man,
hey, Lottie. You need to mute your watch page because you're echoing. Lottie.
Your watch page is muted and your mic is shagged, so I've kicked you out for that reason. So it seems to me that we've just presented to you a couple of things, Circle Dude, and basically one is a working model where we just see things because they're there and no explanation whatsoever is required, but you reject that out of hand because Aristotle told you that sticks in the ground prove it. Sorry?
Aristophanes
says that the sticks in the ground prove it's a globe. So in essence, you reject the evidence that is presented to you that works.
Oh no, I'm not rejecting it.
Well, we've just okay, I'll say it one more time and then you can tell me whether or not you accept it or not. We have a working model that demonstrates direct lines of sight with the lighthouse, the mountains, the topology that you can use to accurately measure with direct straight line measurements, anything on the island. We also have a globe model that can't do that and fails and doesn't represent what is on the sphere and accounts for it with refraction. because the things physically are not there. You cannot see them. Seeing them is an impossibility, geometrically speaking, if you believe you live on a globe. So we have two models, two alternatives to choose from. One accounts for things, one doesn't account for things and needs a band-aid to help account for things that should not be there. You're saying, I reject that. If you're now contradicting my assertion that you have rejected that, please correct me and say, no, I accept that we can see them on your model.
Oh no, I accept that I could see them on your model.
So you accept that model?
Welcome to the flat Earth.
Welcome to being a flat
was it?
earther.
Well, there's
Quite,
still
quite
things
right.
missing
Oh,
off your model,
I'm
isn't
sorry.
there?
I'm sorry, mate. I'm lagging. Can you repeat that last statement?
So if you accept the model that accounts for the observation, you are accepting the model of a flat plane reality over and above a sphere reality that does not account for the items actually being there because they are not there. So if you accept the model that actually works, you are accepting that the Earth is a flat plane.
Can I explain to you why I believe the globe concept works?
No, I'm asking you to explain why you either accept or reject the model that works of this observation. You asked me for my evidence. My evidence is this observation being modelled. You now want to tell me why you accept you're on a globe, and I want to know why you either reject what I've just told you or accept what I've just told you.
All right, so I'm going to decline your...
Can I answer it? I'll answer it.
And can I explain
You
to
can
you
in a minute,
why
Alex.
I believe in the globe concept? Like, personally, why I believe in the globe concept.
No, the specific question is, you've asked us what our evidence is. The answer we have given you. Now you want to move on to a different subject. I want to know specifically. I want to know specifically why, when I have given you a working model that represents the observation, why you would reject that.
Why would you reject that? Well, obviously, you take into vantage point. Obviously, like if I'm at the top of the lighthouse, correct? Say I'm at the top of the lighthouse, and say I'm at the bottom of the lighthouse. So if we were on a flat,
you're just now talking
correct?
nonsense. Sorry, you're talking complete nonsense. So say I'm at the top of the lighthouse, say I'm at the bottom of the lighthouse. That's a contradiction. So your opening statement is complete nonsense.
Say if my friend's at the top of the lighthouse and I'm at the bottom of the lighthouse, how come he doesn't see directly straight down diagonally?
Right, that's a ridiculous question that has nothing to do with the relationship to the observation and the model that I've just explained to you. The observation is from St. Bees looking at the lighthouse. The lighthouse appears in the picture and is accountable on a flat model. It is not physically there on a sphere. I would like to know why, if you do reject it, why you reject the model that accounts for the lighthouse being seen.
Well, the lighthouse being all right. So let me go back to you. I'm gonna answer your question. All right. So you have 8 foot. So let's go back. Let's rehash. You have 8 foot door. You have lighthouse 30 feet under. We're 100 feet above. So that, and then you have a 165-foot wall. Where and the wall's right in front of you. Correct?
Are you dumb? I've explained this twice.
Are you dumb? What?
I'll explain it a third time because you're either ignorant or stupid. So if you're ignorant, that's no problem. I can explain it again for the ignorant. You are standing at St. Bees. Between you and the lighthouse is a 165-foot wall blocking your view. Also, the lighthouse is physically 650 feet below your feet. You cannot see it. It is not there. Seeing it is a geometric impossibility on a sphere, on a globe. On the flat plane, the observation is accounted for with a simple, direct line of sight. Do you understand? Yes or no?
Oh, of course I understand. Well, the thing is, you have to take into accountability. Vanishing point happens within.
It hasn't vanished.
10 miles,
Why are you talking about a vanishing point? The lighthouse hasn't vanished. We see it. That's the problem for the globe. Nothing to do with vanishing points. Nothing has vanished. We see the lighthouse. You said you understood. Clearly you don't.
Yes, I understood.
Would you like me to explain it to you a fourth time?
To me is an earthquake because you're saying it's right under us with a 165-foot wall blocking our view.
Correct.
Explain to me an earthquake. Lighthouse is underground now?
Yeah, the lighthouse is 650 feet below you on the other side of a curve.
Hello?
Leave the
Hello?
silence.
Sorry.
Let this dumbass sit in silence while he comprehends his own bullshit.
No, no, you're lagging, mate. I couldn't hear a word you said.
Yeah, it cut out there for quite a while, didn't it?
No, explain that. Explain that again, because
No
you're talking
problem.
about
I'll explain it
160-foot wall.
for a fifth time if you can shut your mouth long enough to hear it. Right? I don't care about lag. I talk long enough to exclude the lag. So I'll explain it for a fifth time. It's simple. You're standing at St. Bees and you're looking at a lighthouse that you can see. In the flat plane, that's the end of the explanation. You see it because it's there. And modelling that observation, you can then calculate any other point on the island. You can get direct lines of sight and make accurate measurements using a flat model. That's what you can do if you model this observation on a flat plane. However, if you model it on a sphere, the lighthouse isn't physically there. It's not physically seen because there is a 165-foot wall blocking your view of the lighthouse, and on the other side of that curved hill we call a wall, it is 650 feet below your feet. That's how a sphere works. Do you understand? Third time of me asking.
A sphere works from something being directly below me, blocking my side of view.
Yes, if you're standing on a sphere and something is on the other side of the curve and you point your camera towards the bulge, then yes, there is a 165-foot wall obscuring your view of that lighthouse, which is 650 feet below your feet. That's the sixth time I've said this.
I think the guy's trolling, Nathan. I honestly think he's trolling. He can't be that
No, he's
stupid.
just
not to
dense.
understand
Like
it.
most people who
it's
think they
because
live on a
that's
sphere, he
No,
can't
no,
actually
guys.
comprehend and wrap his own head around the absolute nonsense bullshit that is necessitated to actually believe that you live on a sphere. And out of hand, he will reject the single sentence that a flat earther will say, which is that we see the lighthouse because it is there. End of explanation. That is rejected out of hand, and now we've had, what, 15 minutes of complete nonsense from a retard? Because he doesn't understand his own model.
Retard is a slightly offensive word, mate.
Yes, your brain can't comprehend simple concepts like wall and not seeing through a door. That makes you a
Somebody needs to
retard.
build
Your
a
brain
wall
seems to have
through your
retarded
common sense.
to the level of about a 6-year-old that can't comprehend that if you've got a wall
Mate,
in front of you, you
mate,
can't
you're
see through it.
chemically imbalanced.
You're asking me
Mate,
to
you're
explain
chemically
something that is
imbalanced.
incredibly
Alright,
simple
so I'm gonna switch the
6
subject.
times.
What's holding up our sun and what's holding up our moon? And why do they gravitate over each other? Explain the equinox if the Earth is flat.
So basically, you're here to troll us about the equinox rather than address that we have an observation that is absolutely unaccounted for on a sphere 24,900 miles in circumference.
The Earth is flat.
Yeah,
So
but
you're not
black
going to
circles
address.
have-
You're not going to
is
address
that-
the observation. Then you're going to talk about the equinox.
goodness.
You asked me for my proof. I've given it you. You've done two things: ignored it and moved on to the equinox. And basically,
The reason I ignored it is because your math is flawed. 600
I
feet directly below
see.
you
So
does
it's
not
because
equal-
you think
indeed
we've got
do
the
not
maths
equal a sphere.
wrong. How quaint. How lovely. From the guy who asked us to explain why you can't see through a 165-foot wall 6 times. You think we've got the maths wrong.
Well,
okay,
the
buddy.
wall is right in
Good
front
to
of you,
know.
right? It's pretty-
Good to know.
like,
I'll explain
the
a few
math-
more
the
simple
math is pretty
concepts
much
to you so you
common
can
sense,
tell
dude.
me that I don't understand the maths, right? I'll explain the simple concept to you a 7th time so you can come back to me with I don't
simple
understand the maths.
concept.
Yeah. That's why I called you a retard, because it would seem that your level of comprehension is that of a 6-year-old.
Oh man. Oh man. I'm recording this.
You're recording you sounding like a retard. Good.
No, I'm just recording your flawed math.
The math's not flawed. The math is based on a sphere. that is 24,900 miles in circumference. The math for your sphere is absolutely set in stone. It's never going to change. The sphere's not going to get bigger. You're not going to be able to see this lighthouse sometime. It's not there on your model. That's a fact. Don't have to like it. Don't have to accept it. You can tell me I've got the maths wrong. We haven't. Your model just doesn't work.
And realize the Earth is not a perfect sphere. You realize
Oh,
there's a
so it
bulge
needs
in
to be a
the
bit
equator.
less
In fact-
spherical, does
in
it, to
fact,
make this
I'm not
model
sure
work?
that- I'm not
Okay,
sure anybody
okay,
knows
buddy.
the
We're
exact
already
model
pointing the camera
of
down at the
Earth.
horizon, which nobody does. But that's okay. If you want to try and change the balliness of the ball a bit more to make it work in your
Yeah,
world,
like,
that's fine
no-
by me,
no
buddy. You
one
do whatever you
knows
like.
entirely what
You
the
spend
Earth
your life in
is
cognitive
rounded out
dissonance,
to
my
be.
friend.
Neil deGrasse
Convince
Tyson
yourself
stated it's
by whatever
probably shaped
means
like
you
a pear.
choose.
There's definitely a bulge in the equator.
Oh,
First of all.
definitely, definitely. Even though we don't see it in this image that we've just explained to you 7 times. It's not there. We see the lighthouse. There is
that
no
image, is that, where's that picture taken from?
Oh, sorry.
I'm
Did
sorry,
you
I
not
wasn't
hear
paying
that?
attention. I was
Are you
new.
seriously
So
going to
I
ask
just
me to
came in
explain
like
it for an
10
8th time? I don't mind. So, for the 8th time, you're standing at St. Bees and you're looking at a lighthouse. We see it. It is definitely there. However, when you come to model that lighthouse on a sphere, 24,900 miles in circumference, you cannot see the lighthouse. It is not there. There is a wall of water obscuring your view of it that is 165 feet high, and the lighthouse sits 650 feet below your feet. The lighthouse is not there. You can't see it. Seeing it is a geometric
Did you say it's
impossibility.
how far did you say it was again?
31 miles away. 31.5 to be
31
exact.
miles.
31.5.
And we can't see it with our bare eyes.
Yes, we can see it with our bare eyes, you retard. I've explained it 8 times.
You can't see it bare eye. You realize a human sight can only go up to at least 3 miles, probably
Right.
even less.
We have
Huh?
amazing technology and
3 miles.
Yeah,
You can only
tell
see
us-
3
Whoa, whoa,
miles.
whoa, 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 whoa,
Probably
whoa.
I have to call you out on
A
that.
human
Oh,
Oh,
here we
black
go.
circle, black
31
circle, black
miles
circle, black circle. How far are the stars?
How far are the start? Well,
3 miles.
definitely if you take
3 miles
Are they
according to
only
this
3
thing.
miles?
It's
Got 3
definitely
miles.
650,000 kilometers.
when you finish
out
trolling
would
him,
be
3
space,
miles,
and
he
stars would
thinks.
be even
3
farther.
miles to the stars,
But
eh,
stars are
buddy?
light.
This guy's great. I like you.
Stars
You
are
can
gas
come back.
that
How far is
are-
the star?
I love
Nathan.
stupid
Bright
people. They make me
Nathan.
laugh so much.
Nathan.
Funny.
Nathan.
Light
Can I just
travels
make a
through
request,
space,
Nate?
correct?
Nath, guys, excuse me, guys. Can I just interrupt? This guy's had a lot of mic time, and to be fair, Alex has sat waiting patiently, and I'm sure he's got something to say.
I agree.
Can we move to Alex because he is trolling?
I
Absolutely.
agree. I'd
yeah.
much rather hear from
I'm not
Alex.
trolling. It's just that the math is
Yeah, can
simply
you shut up now?
flawed.
Other people want to
He's
talk.
explaining a
Yeah, shut your mouth. Hi, Alex.
Hi.
Hi,
Um,
Alex.
Hi. So, how you doing, by the way? How's everyone?
Yeah.
Good, really
Very
good. Lots of sea air.
Good.
Feeling good.
Can I just say it feels really homely seeing somebody like Alex in chat right now.
Liz, I'm glad to see you, Alex. I've got to be honest.
Oh, I probably won't
Get us
laugh.
down.
Let's try and keep the good vibe. Right. Anyway, but you know, you're saying that this lighthouse thing, but like, I did it quickly, right? And the focal height is what? Hang on, I've got to go back on my phone. So the focal height of the lighthouse. You're talking about Morgold, yeah? We're talking about that one, yeah?
Yeah, we're not
Yeah.
looking at the light, though,
Yeah, yeah,
Alex. You understand that we're not looking at the light. You understand that, right? The focal
I
height's
know
irrelevant.
the focal height, and then the tower height is 23 meters. So you can sort of, and I know we've gone through this before, but it is what we went through before, isn't it? So it's what Rick was trying to tell you ages ago, that when you do the calculations, it's only like 215 feet of drop from like 100 plus feet
No, it
of
isn't.
observation at
No,
30
wrong.
miles, 31
Incorrect.
miles.
Wrong. No, it
So
isn't.
you're not looking at that much refraction.
No, no. Oh, right. Before we've even established what I've just established firmly 8 times, geometrically impossible to see on a sphere 24,900 miles in circumference, Alex. Are you saying that's wrong?
Yeah, I think.
Right,
it's
well then, I'm sorry, but you need to do a bit more homework, my friend. Because...
Well, I only did a little bit. They
Ah,
just seem
well,
like-
that's okay. I'll explain it to you again. I don't mind. It's not
Okay.
technically the 9th time, it's technically the 1st time. Alex, there is a 650-foot drop between your position and Morgold Lighthouse. 650 feet is how far that lighthouse is below your feet in actual reality. I know you want to go straight to the bullshit mathematics of refraction,
No,
but you
no.
still
Don't need
have
that
to
start
accept
with.
Sorry, say again.
No, because what I'm saying is it's not 650 feet. The drop, that's if you were standing at sea level. So if you're standing on the beach and take that photo...
No, Alex. No. It's much worse, Alex. It's much worse. Hello, new guest. How you doing?
Hello.
Can you hear us, new guest?
Yeah.
Hey,
No?
Lottie.
Okay, sorry. Don't want to get us all sniped. Sorry, Alex, you're wrong. It's actually much worse than 650 feet. But according to Metabunk, people tip their cameras down towards the horizon. So in fact, until you breach the bulge, it doesn't change in elevation according to Metabunk because you're always pointing your camera at the horizon according to them. So you've got this bulge that's above you, defying gravity. I thought I was on top of the bulge, but according to Mick West, that doesn't really matter. How you doing, P? Good to have you.
Hey, good.
Hey, P.
So, yes, it is definitely below your feet, Alex, and there's definitely a wall in the way, Alex. That's the geometry of the Earth.
Yeah, but what I'm saying is when you do the curve calculator, Nathan, that it says that it's only 215 feet of drop if you're 100, because if you're 100 feet elevation, it was a bit different when we thought we were at 30 feet elevation, but when you're at 100 feet elevation, then that significantly reduces if you use the curve calculator at 31
But
miles.
the highest point,
No, it
Alex,
doesn't.
was measured at 82
No, I
feet.
just need to correct Alex. Alex,
Yeah.
go and look at the maths and go and have a look at the drop value. It doesn't change because the camera angle varies in Metabunk's calculations. It's a bit of sleight of hand. That's what it is.
I'm not talking about the camera angle. I'm just talking about.
Now, I am talking about the camera angle. The drop value doesn't change regardless of if you go up another 10 feet or 20 feet or 50 feet. The drop value on that calculator remains the same.
Yeah.
Right.
But what do you think the drop value is, Nathan? It's
How
from when
far
you're at the
it's
sea
dropped?
level.
How far it's dropped? How far
Yeah,
below
I know,
you it is?
But you like so if you're
Do you know how a
like you're
curve
saying with
works,
the wall,
Alex? Do, you know,
you're
do
talking
I
about
have to
your
now
wall.
explain to you how a bloody hill works?
No, but that's what I'm going to. So you talk about your hill. So if I'm standing, there's a hill in my way, and then if I go up 100 feet, I'm going to be able to see over more of that hill. And
Right,
eventually,
the
if I go
hill
over
is
the size of the hill, I'll see
165
over the
feet,
hill.
Alex. Right,
how
so you're
hill-
looking, Alex, you're looking at 165 feet high hill. Do you think if I go to 130 feet, I can see over the top of that hill?
You'll start to see more if there's anything.
Yeah, you'll start to see the
more.
mountains, but not the bloody
because
lighthouse, Alex.
Yeah, because remember we're not. Yeah, but remember the drop
Not
value. We're not
the
talking about hills,
lighthouse,
not the
though,
best.
Alex. So yes,
I
you
mean-
can see above the hill, and you can
Hang on,
see
can
the
I finish my
mountains in
point?
your model. Yeah, but the lighthouse you can't see. There's still a hill in the way.
Right. No. Yeah, but remember the hill isn't the best
Hey, look.
analogy, Nathan, because you're always on top of the hill. Anyway,
No,
you're not, the hill
right,
is-
Alex. No, you're not.
Yeah.
No, you're
You
not.
are. You're looking down the hill, remember?
Alex, I've got to explain this to you because you've just made a fallacious statement. You're always on the top of the hill according to gravity. According to Mick West, you can look through a bulge that's higher than you. That's what Mick West does with his tricky maths.
Well, no, because it's not a bulge, is it? It's a drop. Like that's why it's called the drop value.
Are
You've
you
got
disagreeing
both.
with Mick West?
There's more than
No, I
one.
don't- you
There's
know
more than
Mick
one
West
factor
is-
to look
Yeah,
at,
but hold
Alex.
on, Alex,
You
this
seem to
isn't
want to
really
look at one
important.
thing in
I've really
isolation.
only seen him
Why
like
things
when you
don't get
I've
resolved,
stated the
Kat? Are
facts
you
to Alex
disagreeing?
9 times. He doesn't want to accept them. This is the reality
No.
based on your fudged maths. The drop value is more than 650 feet, geometrically speaking, but based on Metabunk's fudged maths, I use your limited drop value of 650. That's
Yeah, but
reality
Nathan, what do you
according
think
to Mick
drop
West's
means?
maths.
What does that imply
It
if it's a
is
drop?
below you. There is a
Yeah.
wall in the way.
Yeah, it's below you. No, what does a drop imply, Nathan? It's
That it's
dropping.
bloody below you.
It's dropping though, isn't it? That's the point
Yeah.
I'm making. So you're not looking over a hill. You're not trying to clear a hill.
That's what
There's
Metabunk
construct-
says you do. I don't make the rules up for your sphere and how you want to calculate bullshit on it. I don't care.
It's a sphere.
What I can take from
But
that.
this is what we're talking about, Nathan. We're talking about calculating what's on a sphere. So
Yeah,
you
and
saying
reality,
there's a hill and a
according
wall is
to
silly.
Mick
It's a
West,
drop.
is that it's 650 feet below you and there's a 165-foot wall in the way.
Well, it's a drop, isn't it? This is what we're saying. You're on a sphere. Can you not picture
so what,
that you're on a sphere and
Alex,
it's a
just
drop?
answer me this question. Do you accept that you cannot see that lighthouse on the sphere? Yes or no?
I accept you can't see some of it because of that refraction as well, but I don't accept that you couldn't see the light. No, because from the calculations you should actually see the light in reality.
We're not looking at the light, we are looking at
No,
a picture
hologram.
of the lighthouse. Right.
Yeah,
So I
yeah,
will
but
say
yeah,
it
no, I
once
agree
more,
with what
and
some of
hopefully
what
I will
you're
get a
saying.
yes or no straight answer without a load of
it
bullshit
can't be,
concessions
because
afterwards,
okay,
Alex.
if you're talking about under the light of the lighthouse, the rocks
No.
underneath, yes.
I'm
I
talking
agree.
about on a
I agree
sphere.
with that.
Let me get to the end of it, Alex. I'll phrase it as a question. on a sphere 24,900 miles in circumference, do you accept that if you simply stand at St. Bees and look out, the lighthouse is physically not there because it's on the other side of a hill? Yes
No.
or no?
No.
So you're just saying no, it isn't.
Because it's it's not.
Alex, slow down.
I've already explained it 100 times. It's a drop. It's not, and you can see some of it. According to just what I did, and I'm not a
No, you
genius, it's
can't.
what I did on the calculator.
Alex,
It should be able to see some of it, yeah.
You can't
Alex, some of
see
it
it.
like
It's
what?
not
The
there.
top?
It's
The
physically impossible to see. It's not a possibility. Seeing the lighthouse is a geometric impossibility.
No. Some of it isn't. That's what I'm saying. So if you
No,
do
not
the
some of it,
calculations
Alex. What part of 165-foot wall don't you understand?
No, what part of? Well, okay, just do the curve calculator here. If you're so sure about it, just do
I've
it
done
now.
it.
Let's
I've
do
done
not
it.
on-
I know the maths.
No, but
I
let's
know
do it now on
exactly
screen,
how
'cause I've done
far.
it here, and I'm disagreeing with you. That's what
Right.
I'm saying. So maybe I've got
Alex,
something wrong. You can show me.
I'm telling
I'm saying
you
that the obstruction is
facts.
like 213 feet
Nothing
from
will
your
change
observer height.
the fact.
Not drop. I'm talking about obstruction.
Just show him. Somebody get the calculator. Bob.
Yeah.
You need to
Just
show him.
me.
Alex
Shut me
is
up.
speaking from a position of ignorance, telling me that you can see a little bit of it, and geometrically, it's gone. It's not there.
Show me
You
that,
can't see
Nathan.
it.
Show me that.
We've
Show
shown
it
it
to
in
me
plenty
now.
of demonstrations, Alex. We've shown it. We've done it
But
in
I've tried to
demonstration
do it
after
here,
demonstration
and it
after
seems to be
demonstration.
that-
You just deny them. We have had a demonstration called QED, obviously and observably flat, where we model how much of the lighthouse should be obscured by the hill. You have seen this. If you want to deny it, that's fine. It has been demonstrated. QED.
No, it hasn't.
Yes, it has.
Well,
You're
how
just
hard would
denying
be to
it.
Just do the calculator and shut me up right now.
I've done it. I've done it multiple times. I've done it hundreds of times. You're
Right.
just denying it and want me to do it again. And there's no
Yeah,
point.
because my calculator,
Just a
the calculator's
denier.
here, Nathan.
Alex,
It says
you're
that
just
there's
a denier.
210 hidden.
You're just a
and that
denier.
The focal point is at 213.
Focal point is irrelevant. We're
So-
not looking at the light.
That's where the light would be. That's where the light
The
would be.
light
So you would
isn't
see
what
the
we are
light on the
looking at,
sphere.
you moron. How many times do I have to say it? The light isn't what we're looking
Yeah.
at.
Yeah, but this is what
Yeah,
I'm
but
saying.
what I'm
We
saying
know-
is it's not a geometric impossibility to
that
look
we're
at the
looking at
lighthouse
light.
because the light is part of the lighthouse.
The light
explain that
isn't
light.
what we are looking at. What part of
Yeah,
that
but the light
sentence
is
don't you
part of-
get?
The reason I
Alex,
can't
are you
agree
dense?
with you, Nathan?
Are you
Can just let me
dense?
speak? No.
Are you thick?
I think this makes sense. What I'm saying. The reason I say you can see the lighthouse is because the light is part of the lighthouse.
It
So
was
if
in the
if calculator
daytime.
says
The light
the
wasn't
light,
on.
I can't-
Let me say it. I'm going to put you on mute so that the audience can hear me say it. The light was not on.
Am I back? Sorry. Yeah, but the light, whether the light is on or not, the light's still there, is what I'm saying.
No,
the light is
lights
there.
that
It's-
aren't
whether it's turned
on,
or not.
you
there.
dumb
Light bulb is
idiot.
there.
Lights
The
that
light
aren't
bulb.
on don't produce light. You
It's
understand that?
just a bulb, Alex. It's not a light. It's a
I
bulb.
think you're really missing the point of what I'm
No,
saying.
I'm not missing the
light-
point.
the
You're
focal
trying to
height
get
is
me
where
to
the
confirm
light
that we
shines
see
from.
what
That's
light
the
at what
light.
height,
The light
and I'm
is
not going to do
The
it.
light is on.
We're not looking at the
is
light.
off, mate.
We're looking at the lighthouse and its base and its
The
foundations.
lighthouse. What
And
do you think
it
is on top of
is-
the lights? The lighthouse.
it
The light
is
is in the lighthouse.
650
Top of the light-
feet below your feet on the other side of a curve, and there is a 165-foot wall obscuring your view. You can talk over me and try and obfuscate this point and try and deny it as much as you like. Seeing that lighthouse is a geometric impossibility on a sphere.
Can I ask a question? Simple. Is the light, right, in a lighthouse part of the lighthouse, the building? Is that
It's
part of
not.
the structure?
No, on this occasion, no. The
On
lighthouse
this occasion, no. But any
No.
other occasion, the light is part of the lighthouse.
No,
The-
you
the
can have
housing
plenty
where
of
they put the hole.
lighthouses that you could do the exact same
What?
observation on that are decommissioned and don't even have a bulb in them, and you could do the same
Yeah, but
observation.
it doesn't need a bulb, Nathan, because the focal height just tells you where the bulb would be.
Focal
Even
height
if
is in
it's
relation
smashed or
to the
removed,
focal
still
height
that's
of the
height.
light it produces, you stupid idiot. The light
Alex,
that produces has
let's
a
put it
focal
another way,
height,
Alex.
What do you
not
think
the
the
lighthouse,
focal
it's a
point is where
building.
the light comes from.
Yeah, there's
Alex.
no light, you stupid idiot. How many more times do I have to
Doesn't
say
matter
it?
if there's no
It's
light
not
there. That's
on.
The point of height. It's giving you a reference, Nathan. Can you not understand of how high the building is?
No,
From
how
sitting-
high the
Are you
light
saying the whole of
is.
the top of the lighthouse
How
is
many
just
times
one
do I have to
big
say
bulb?
this to Alex the retard?
Who did
The
this?
light isn't on. The reference for the light is irrelevant. We don't need to know what the light does. The focal height means
You just
nothing
need to know where the
when
light
we are
bulb is
looking at a
positioned
building.
above-
Why are you talking over me, Alex? Are you just here to obfuscate this point? Is that your purpose in life at the moment, to come and obfuscate this point? Alex wants us to talk about the focal height, which I absolutely unequivocally stopped Rumpus from doing. No, we're not going to take into account the focal height because it's irrelevant. We're looking at a building.
What? So the top of the lighthouse is irrelevant. The top of the building.
The top of the
When we're
building's
talking about what we
above.
can see.
Top of- top of the
Sorry,
elevator,
Alex.
you can see the bottom of
Alex, we can see the bottom of it, not the top of it. We see the bottom. We see the foundations.
Yeah, but you're. Yes, I understand that, Nathan, and that's
Right,
where
so
I
what
agree
the
with
hell
you.
does it matter
I
where the
said-
bloody
I
light
said-
is? Who
because-
cares where the
yes,
light is? We
because
see the base of it.
Well, why did I say it mattered? Have you been listening to me? Why did I say it mattered? Because I have been listening.
Because
to
you're
you,
trying
but
to
why
look
did
for a
I
light
say
that's
it
not
does
there.
matter?
I know why you think it matters, because you're looking for a light that's
So
not
why are
there
you
based on the
asking me why it
focal
matters?
height. Well, if
Oh,
we
but
see the
let
base of it,
Alex-
Alex,
let
the
Alex
light's
I already
irrelevant.
know. Why do you keep asking me the same thing and
Alex,
then getting angry
get
when I
it
give you the
out,
same
get it out.
answer?
Yeah, because
Hear
you're
what I
dumb.
want to
Because
say.
you're dumb and you
As
keep
far
asking
as
me
it-
about a
as
light
it
that's
stands,
not
it looks
turned
like
on.
You're saying a light. Yeah, we're not talking about a light, Alex. We're talking about a building. Yeah, well-
I'm not kicking out the light over.
Okay, so none of the lighthouse, the bottom should not be seen. It's
I agree with
seen.
that. Yes.
So if you agree it's seen, what's the problem?
Yeah. That's where I agree with you. But do you understand what I'm saying? Why you telling me?
No, I
that
don't. That's what I'm
can't-
saying. I don't
Okay,
understand.
so suppose what I'm trying to say is that I don't care about if the light's in there or if it's turned on or it's
Alex, just,
decommissioned.
can you
or
click
anything.
on Sleeping
No,
Warrior's
please,
screen, Alex, please?
Please,
Can you click-
please let me finish.
No,
because you see.
No, I'm not going to
All
let
right.
you obfuscate the point.
You
and talk
you
about a
obfuscate
light.
then, Nathan. Carry on.
You look
Continue,
at.
it's your show.
Please, can you click on Sleeping Warrior's screen and tell us what
No.
you see?
No, why should I? You won't let me finish my point.
No,
Just
no,
keep-
let him finish.
This
please,
is the
Alex.
observation.
Just say
This is
what
our
you have to say,
proof that
why
you're
you-
denying.
nah,
This is
why
the
you
picture of the
answer this.
lighthouse we're talking about. You just don't want to look at it.
No, you why should I look at something when you won't let me finish a point? You wouldn't even bring up a simple curve calculator to prove the point. Because you know
Curve
what I'm saying is
calculator is
true.
irrelevant. In geometry,
Ah,
the lighthouse
very
doesn't
good.
appear. It doesn't matter about what the curve calcs say. Geometrically, it is impossible to see this lighthouse on a sphere. That
No,
is
it's not.
a fact.
No, it's not. That's what we're arguing about, and that's what I want
No,
to explain.
it is a
why I'm saying it's
fact.
not
It is
impossible
a
to see the lighthouse.
geometric impossibility to
Without
see this
refraction, I agree
lighthouse
you shouldn't see the
at
bottom of the lighthouse.
31 miles. It has gone. It is no longer there. That is why refraction, according to your bullshit, has to, quote, bring it back. It's bringing it back from beyond your view, you moron.
And the reason you don't want me to make this point, Nathan, is because once I demonstrate you can see some of the lighthouse, some of the top of the lighthouse, and it is a geometric possibility on a sphere, then the refraction's fairly negligible you're looking at in your photo. And that's what you don't want to see, because
I've
you
just
want everyone
tried to
think
get
there's
you to look at this
huge
picture.
amount of
Are we
refraction,
seeing?
where the reality is it's not
Are
that much
we
refraction.
seeing some of the
Very-
lighthouse sat on the horizon, or are we seeing all of the lighthouse and its base, negating the need to worry about the tippy top of it? Are we seeing the top of it or all of it?
If there's no refraction, we should only see the top of it, tippy top.
So
Of it.
what are we seeing in
Right,
this picture?
what are we seeing
Yeah.
on screen though, Alex? Click
We're
on
seeing the
Sleeping
whole of
Warrior
the
and
light.
tell me what you see.
How is that possible from this
The
observer
refraction,
height?
because there's a very small amount of refraction. We're
Right,
not talking about
Alex,
a lot, like a
I'm going to
couple
say
of-
it one
20
more time. I am not talking about refraction. That is the Band-Aid theory that gets around the fact that you can't see it on a sphere, you moron. I will say it one more time for Alex, the complete idiot who can't understand simple geometry, even though it's been explained on this show 12 times. Right, Alex, I'm going to explain it one last time for you. Seeing it is a geometric impossibility on a sphere Earth. You can't see it. It is not there. There is a wall in the way that is
We see it
165
because
feet.
it's there, easy, observably fact. I get it, Nathan. I've heard it, but what I'm saying is, you can't explain why you can't see the whole of the bottom of the shoreline. And
Sure
this
we
is
can.
the thing you saw on Chris Monk's video the other day. You saw the whole of the bottom
So
of the shoreline.
Alex
when
is
he
now
put it on the
obfuscating the
platform.
point. Has he yet
No,
conceded?
it's not.
How are
You
you
don't
going
believe
to
in refraction,
concede,
and I don't
Alex?
believe in dirty air. That's what it comes down to.
Alex
So
has now
when you're
changed
saying
the
my
subject.
model's not complete,
We're
well, I say
talking
that to
about
yours.
we're
Dirty
talking
air.
about the lighthouse, and Alex wants to talk about the top of it. I've got him cornered
Yeah.
to the point where he needs to either
No.
accept that seeing it is a geometric impossibility,
If
and
I can
instead,
see the top of the
instead, Alex is talking over me constantly and trying to get us to move to the bottom part. So he's gone from the top of the lighthouse to the shore. What a shock! Alex doesn't want to actually address the fact that it's a geometric impossibility to see the lighthouse at all, and instead wants to talk about either the tippy top of the lighthouse or the shoreline. He won't talk about the lighthouse itself and accept that it's a geometric impossibility to see it on a
Is the
sphere.
top of the lighthouse part of the lighthouse, Nathan?
We see all of the lighthouse.
So
it's like the
that's
lights
the point
that
I'm
we
making.
don't see,
It's
Alex.
not geometrically impossible, is it? If I can see some of it without refraction.
Not some of it,
with
Alex.
mathematics on a ball.
All of it.
That's all the point I'm making. I think everyone can hear that.
No,
That's
Alex,
the only point.
Alex, I don't think
I'm
you're
willing to
on
go
purpose,
and agree with you, Nathan.
You're
but
talking
can't
about, you keep using the word some.
Yes, but
Where is
Nathan,
the rest of
I'm
the
willing
lighthouse?
to agree with
Where
what some of you're saying. You can't even agree that the top of the
Where is the
lighthouse
rest
is
of that
part of the
lighthouse, Alex?
lighthouse.
Alex, where's the rest of the lighthouse? You said we can see some.
That's
so
what
where
I
is
will
the-
talk to you about, but you can't tell me it's a geometric impossibility.
Okay, I'll
to
ask
see
you a
what the
question then,
lighthouse
Alex.
is.
Alex,
where is the
Alex.
rest?
Isn't.
No,
Said
let's just
some.
ask Alex a
Without
question.
Where's the rest of the lighthouse?
Let's ask Alex
Where's
a
the rest?
question.
Yeah,
Alex.
that's what we can talk about, but can you stop bashing me about saying it's a geometric
No, I'm
It
not
is.
bashing, I'm asking
It is a
you.
geometric
Okay.
impossibility
And
to
I'm
see on a
saying, where
sphere.
is the-
That's
in this
why you're
picture,
using
where
refraction.
is
That's
the
why
rest?
refraction is needed. It is a band-aid theory to get around the fact that you cannot see it on a sphere, seeing it as a geometric impossibility, something that you want to obfuscate and tell me we can see it, we can see it, we can see the tippy top of it. No, Alex. No,
Nathan, what I
Alex.
say to you is what you're trying to do is not let people accept that you could see the tippy top of it
We
on a
can't.
sphere,
We
geometry
can't
with
see
no
it.
refraction.
See that hidden
Because
value,
then,
Alex?
Then you have to consider. No,
See
let me
that
finish,
hidden
Nathan.
value?
Come on.
See that hidden value?
Nathan. You
220
can't even let me
feet.
get a sentence out.
Hidden?
Is that how triggered you are? Right now?
No,
Come on.
you're just not
Look.
accepting the fact that you cannot
No.
see it on a sphere.
So no sentence then. Okay.
There's
Carry on.
no
Saying the same
possibility
thing for the 12th
on
time,
a
13th.
sphere of seeing it. None.
Just keep saying it.
Well, why don't you
So-
accept it?
So the reason Nathan won't let me finish is because once you realise there's not that much refraction, we're only talking about a little bit of the lighthouse
Right.
and some of
What
a little bit of the rocks
refraction
underneath it.
is the band-aid theory to get around the fact that we can't see it on a sphere. So Alex wants to obfuscate these 2 points without conceding the initial fact that you can't see it. That's why you need refraction. If you didn't need refraction, it would be because you could see it. My point is that you can't see it, and you need refraction in order to see it. All Alex wants to do is continually talk over me, while I continually point out that seeing the lighthouse is a geometric impossibility on a sphere. It's gone. It's not there. You can't see it. Nobody's seeing it. It's not there. So you need refraction to bring it back. That's the reality of the situation.
Just
I
wait a
think
sec.
Nathan's lost it, man.
Stop. Nate, just let me have the mic a sec. Alex, just talk to me for a sec. You're saying that with I've got the maths on screen. Can you see my screen?
Oh, okay. Yeah.
Okay, so I've got the evidence and I've got the maths on screen. Just to confirm the maths, do we agree?
Okay.
31.3.
Yeah. I'm happy with that. That's cool.
All right. So without refraction, do we agree that the whole thing's missing?
Hidden...
What do you mean, Yes, it's missing. It's a geometric impossibility
I'm
to see.
looking up Morgold Lighthouse. Oh,
Let him
God.
think about it.
Just give me a minute.
Can I just look up Morgold Lighthouse, please?
Nate, just
What
let
do you
me
mean
speak
look it
with
up?
Nate.
You're asserting that we can see it, and you're now going to tell me that you're going to look up how high it is.
Okay,
This
I
guy,
might agree
Alex,
with you. Can I just look up the
What do you mean
frickin-
look it up? You've just told me we can see it, and now you're going to look it
It's
up.
on my phone. If you give me 2 seconds, I've got
No,
it here.
no,
It
no,
won't
no, no,
take
no.
long.
This is horseshit. You've just asserted and argued with me for ages while I assert that it's a geometric impossibility to see. Now we've brought up the maths like you've asked and shown you it's a geometric impossible to see, and you go, let me have a look at it. Let me go and have a look. Why have you been asserting that I'm incorrect when you haven't even looked it up? Why have
Nate,
you...
just hang on a sec.
I said while I was looking up on my phone. Now you've wasted over 5 minutes of your show complaining and getting triggered like a tit.
Hello,
Just-
everybody. I am triggered because people like you, Alex, don't want to
Calm
accept the
down,
reality of your
Nathan.
own model,
What
and
is
it annoys
stressing
me.
you out so much in
Hello, we
life?
have a new
God.
guest. Oh, we did
It's
have a
stressing me out now. Sorry, hello.
Well, you should be stressed. Your model doesn't
Why
show
is
this
that
lighthouse
stressing
being
you?
there. You constantly
stop.
want to
Nate, can I
obfuscate
speak
and
with
twist
Alex,
the points
please?
together.
Nate, let me speak with Alex for a sec. Alex, you've just agreed that without refraction...
Yeah, I have. Yeah.
Right, so
It's
at this point...
213 foot. Yeah.
Right, so if we apply refraction, what does that tell you?
No.
that we see
Sorry,
on the
this
evidence?
is my point. You just steamrolled at it, Anthony. So, Alex, you've just accepted that geometrically it's not there.
Yeah, Nathan, remember when I asked you to just pull
Yes
it
or
out
no?
earlier and you didn't
I
do it?
want
I
a
would have
yes or
accepted
no
it back then.
from Alex.
It's just on my calculation, it's sticking up by about 10 feet.
Right.
But on
Do you,
Riley's,
do you
it's not.
see
So I was like,
220 feet as the figure
what you
there?
needed to do, Nathan, instead of
Alex.
wasting everyone's time.
Alex,
Please,
Alex,
please.
Alex, I want a yes or no concession from you. This is why I'm annoyed at you. Right.
Okay, I'll concede.
So you can't
Okay, you
see
can't
the
see
thing
the top.
on a sphere. You don't get to see it.
Nathan,
it's not
I
there.
said to you, I
It's
would
a
accept
geometric
that if you pull out
impossibility,
the
Alex.
calculator.
Sorry,
And now I
sorry,
accept
Alex.
it.
Sorry,
What
sorry,
more
Alex.
do you
Just
want,
to
Nathan?
let's just shut Alex. So just so I can make my point now. Alex has conceded and still wants to talk over the top of me. Alex has now conceded something that I have made probably 13 times the same point on this show. Right? The lighthouse isn't visible on a sphere. It's not there. You can't see it. You can't see the tippy top of it, as Alex asserted, before looking it up on his phone, because he asserts things from incredulity. You can't see it. It's not there. It's not visible. We ain't ever seeing it. It's behind the curve of the Earth. And, as stated, it is 165 feet behind a wall. And it is 650 feet below your feet. It is impossible to see. No one's ever going to see that lighthouse, including Alex. He's just talking crap when he claims that you can see the tippy top of it because he wants to obfuscate this very simple fact that you can't see it. You're never going to get to see it, Alex. It's not there. That's simple reality. Whether or not you choose to accept it and choose to obfuscate and talk over and distract from this uncomfortable
I'm the one
detail.
talking over him, Nathan. Do you even listen back to your shows, man? I've sat
Right,
here
guys,
quietly.
stop.
I listen to what you
Alex,
say.
shush.
You can't
Alex.
even.
Alex, talk to me.
Yeah, I know.
Right. So you've just said that at 220, the lighthouse is gone. That means that the horizon, basically it's this line, the horizon would be there. If we're going to go with refraction at 167, wouldn't that mean that the tippy top of it would be peeping over the horizon, and that would then match what we see in the evidence, right? But what do we actually see in the evidence? That's not what we see. So if you argue that we bring back the tippy top,
Hang on, is this little dot here the lighthouse we're talking about?
Can you see my screen?
Yeah. Is that it?
Okay, that's Mackle Lighthouse. So what you're
And then
saying,
that's the horizon's just and that's the black there is the water.
but you're saying that for this to match real world, that you can bring back the tippy tops of it, therefore refraction's done it. The horizon has to be where that line is, because that would be the tippy tops of it. But in actual real world, the horizon is there. So refraction isn't bringing back enough of the image to match what we see. Do you agree?
No.
So
how do I
you
know what the
account for-
refraction was on that day?
But
Says on your
according to the standard
calculator.
So what you're saying is that you agree that standard refraction doesn't bring it back, but you need to go into non-standard refraction.
Well, hang on. So how much does it say the non-standard refraction is on there? With
There
standard
is no
refraction.
non-standard refraction on the calculator. We've
No,
just got
Nathan,
refraction.
you're too triggered, man. We can't have a
No,
conversation.
Alex. I'm explaining it to you because you're
It's
dumb
Riley's
and
show,
you've
man.
been
Let's
here.
talk
We've
about
done 160 shows on it. Now you're saying you need to look at
No,
the height.
we can't
after
talk.
telling me
Nathan.
we can
You're
see
too
it on a
triggered,
globe.
man. You need to calm down,
Yeah,
bro.
I don't need to
Seriously.
calm
If you're not
down
gonna
when
be
you've
polite,
told
it's
me
no
that we
point.
can see the
Count to 10,
tippy top of it
Alex.
on a globe and we can't. You can't see it. It's a geometric
Okay.
impossibility, as
One.
I've stated 100 times, and you've denied that fact. I said it was a fact. It is a fact. You can't see it on a globe. It's a geometric
Yeah, but
impossibility.
you just said it, Nathan. I just wanted you to just show it to me, and you wouldn't do it. All you want to do is be mean and nasty to people.
I said
All you
it's
had
a
to
fact.
do is just
It's a
do what
fact.
Riley's done and say,
It's a
look,
fact.
here
You
you
just
go.
didn't want
It's
to
actually a
accept
little-
it.
It is a little bit under.
Now
We're
we've
talking
proven
about
that
7
fact to
feet
you.
here.
The fact
Yeah, but
remains
look,
the same. I'll tell Alex. The fact hasn't changed. It's still, as stated by me, a geometric impossibility to see it on a sphere.
very close to the horizon, the top of
Not
the
very
lighthouse.
close to the horizon.
Yes,
A
it
geometric
is.
impossibility
I mean,
to see.
yeah, even with your
It is
observer
not
height, 80 feet, 100 feet,
geometrically
120 feet, it's still
possible
close to the
to
horizon.
see.
Right, the point I was making, Alex, is if we're going to go with the 167 feet of refracted hidden, that's the value that's hidden by the horizon. So we know that the according to what it says, we know that the lighthouse is 75 feet in height. Agreed?
What, from the bottom? No, I don't know, actually. No, is it?
The height is 75 feet of the actual building of the lighthouse.
So the focal height is 213 feet.
Focal
So
height's
it includes
irrelevant. We're
everything that
not
goes
looking
down
at
to
the
the
light,
water level.
Alex. Try and
So,
ignore the focal
that's
height.
what I mean.
The
So I
light's
thought
not
the
on.
height. Oh, so you're saying, yeah, the
The
height of
light's
the
not
building is
on.
23 meters.
The light
Okay.
isn't
Nathan,
on.
just calm down.
No
It's not,
light, Alex. No
it's
light.
not worth doing this to yourself, mate.
So what I'm saying is, if we take the 213 feet minus the 75 off the lighthouse, so
Then
we're
you
left
get-
with the rocks that are underneath.
Right, yeah.
Does that then match what we see, or is there still more land
No.
there?
Yeah. That doesn't match what we see. Yeah.
Right. So therefore, it
refraction.
can't be standard refraction. That was the explanation for what we're seeing.
Oh my god. Okay, let me write it down. God damn it.
So we have to go into the
Yeah.
non-standard refraction, right? This is the bit where it becomes perverse.
But no, but even though my calculations do show that we would see a little bit, yeah, but I'm still not that far off what you're saying. The oh god, I just saw Ali B reads chat and I read chat. The refraction's hardly anything really. We're talking about just bringing the building back 23 meters roughly, plus a bit of the rocks underneath.
No, that's not what we're talking about.
30, 40 meters.
No,
Alex, what
that's
you're
not
saying is we're
talking
talking about just bringing the building back. And what I'm saying is, even with the refracted hidden, we're not bringing the building back because there's still 167 feet of refracted hidden. That's not bringing back the building. It's still obscuring the building, but we see the building. So however high you want to, wherever you want to put this to represent that value, we still see more than it. So it means that you have to go into non-standard refraction.
But yeah, maybe I'm getting this wrong, but you're saying like we have to bring 160 feet back. But if the building's only 75 foot, right, and the focal height's 213 foot, there seems to be a hell of a lot missing still.
No, there's a lot more in the evidence.
No, why is there so much missing? Is my point. If we're talking about how much we need to bring back, I'm talking about why can't we need to bring all of it back, right?
Yeah, but when you're bringing back the lighthouse, you're bringing it back from the bottom. You're not bringing it back from the top. Do you understand that?
Yeah.
Because
it's coming from the bottom. Yeah, it's going up.
Yeah, because the horizon's dropping, so you got to bring back the whole of the lighthouse at 75 feet to match what we see, and some of the rocks underneath.
Some of the rocks, but not all. But yeah, this is the problem. Like, where's all of the rocks? You know, there is something being hidden. So, yeah, we can argue about the refraction, which we don't know how much it was at the time.
Well, we know that
the ultimate point is there's something hidden, which it shouldn't be if it was flat.
But Sly Sparkane has helped us recently. He told us that it wasn't curvature that we were looking at. He told us that it was a bit of mirage. I think he called it inverted reflection or something of that kilter, but it wasn't curvature. So maybe you should go and ask Sly Sparkane.
Well, I don't know. I don't really listen to Sly, but I
could bring it up if you wanted. Would you like to see his comments?
Yeah, let's have a look. Let's want to clear this up.
Okay. So I'm just trying to remember where his comment was. Which
Steve Anthony, shout out.
I'll do it from my video itself because I can't remember which video it was in off the top of my head.
Funny that comes up on your suggestions, Riley. You've been watching a lot of the debate server.
Huh?
Have you been watching a lot of the debate server, Flat Earth, and more?
I'm not sure.
Judging by their view count, I would say no.
So Sly says, I'm going to get to the part in the video where it says it so I can read it. So, Sly says, come on, hopefully I'm going to highlight it and show you. I ask him what the current science is to explain why the land on the north side appears to be floating. And then he responds after a while, and he says, Scott Veach thinks that Fata Morganas are inferior mirages. We'll ignore that bit. Then he says, just trying to find, there we go. So, you guys claim that it is dirty air. This is in reference to the floaty land, which previously you guys say is the curvature of the earth that's obstructing it. But you guys claim that it is dirty air or whatever. And that was done intentionally so that we didn't use a scientific phrase that someone could trip us up with a semantical interpretation.
Oh, I thought it was scientific.
Instead.
Yeah.
But then he says, which from the observer would appear as an obstruction, not a reflection. So what he's saying is that we can see an obstruction to the observer, which is what we call dirty air. So he's describing it as an obstruction, which previously was described as curvature. So he's now acknowledging that there is something that's obstructing us, our sight, but it's not curvature. So what I'm saying is we see it all over the image. We see it with the lighthouse. We see it with the floaty land. There is an obstruction there, but it's a reflection according to Sly. But it appears as an obstruction, not a reflection.
It's the obstruction formerly known as curvature.
Sure.
Right, but it's now known as dirty air.
No, it was known as dirty air because we didn't know what the current science was. But what Sly's
Oh, it's
saying is that
Nathan's Wall. Are we going to? I think we should go back with Nathan's Wall. I think that's a great name.
Yeah, it's
But
the
the point-
obstruction
Or the Great
formerly
Wall of
known
Nathan.
as curvature.
But the point was, getting to the conclusion of the point is that whatever the perception is with regards to the refraction, it brings back it just brings back the tippy tops of it, but the horizon would be basically here. But we see that the horizon is down here somewhere.
Yeah, I know, but it's such a tiny amount you're arguing over. I mean, and the
No,
fact is,
no, it's not.
it
No,
doesn't
no,
show
no.
a flat Earth. We're just
No,
saying,
no.
oh, there should be more convert.
Sorry,
Like,
I want to say
is
this
there more
again.
refraction? Isn't there more
I
refraction?
want to say
Is
this again,
refraction
Alex.
real?
Sorry,
I mean,
I
that's
know
all
you
we're
want to
talking
troll
about.
the living daylights out of me whenever I say this, but I don't care. So, it's not a small amount. It's 650 feet below your feet, and is having to be projected up to sit on top of the horizon in perfect proportions. It's not a small amount. It's a 650-foot hologram.
It's just not, though, is it? I mean, do you agree with that, Riley?
He's right.
Do you think it's
It's a
650
fact.
feet below your feet?
Yeah.
And that's how much hologram is coming up, 650
Yeah.
feet.
According to your
Even though the
model,
focal-
According to your
No, but
model.
Alex, again, according to your model, yes, that's what it
Oh,
implies.
I mean, look. I mean, that's a good picture, actually.
Yeah. We're
Yeah.
seeing all of the
Where's
lighthouse,
the rest of that?
and we're seeing down to somewhere about here. Well, there's a little bit down at the bottom, which we can't account for. But if you're saying that's the curve of the Earth, your model puts the curve up here somewhere. So either it's
Right.
much bigger than what we're
Doesn't
told.
no, that's not
or
right.
it's not
Anthony,
curvature.
that's not correct. That's
so the
not where
curve
the,
is-
that's not. Sorry, I want to correct that. That's not where their model puts the curvature of the Earth. That's a refracted value. They've got all sorts of bending light doing that. The curvature of the Earth is such that you wouldn't see any of this lighthouse, as I've said probably 17 times on this show. Seeing it is a geometric impossibility on a sphere. You can't see it because there's a 165-foot wall in the way, and it's 600 feet below your feet.
No,
I
you got
think
it wrong.
what's- I think
Nathan's
what's
got it.
baffling-
Riley's
I
got
think
it
what's
right.
baffling- Yeah, but I
Riley's
think what's
got it right,
baffling, Alex, what's baffling you
Not-
is
not you,
that
Nathan,
can
sorry.
actually
No,
see
I've got it right.
the lighthouse.
He's right. The horizon's like just above the lighthouse kind of thing.
No, Alex, what you're not doing is you're not realizing that I'm playing both cards at once.
Oh,
Nathan,
my microphone, man.
one card, one play, which is to do with the bulge and the obstruction from the observer. What I'm saying is, if we apply your maths, this is what we should not see. So I'm not agreeing or disagreeing with Nathan. I'm just showing the other side to it, which is even when you apply your maths, this is not brought back.
Yeah. No, I agree. I agree with you saying the horizon should be just above the lighthouse, maybe from your calculation. Anyway.
Did you hear that term though, Alex? Brought back.
Yeah.
What
It's
do you
called
think that
refraction.
means?
I believe
What-
in it, Nathan.
What do you
It's a real
think
thing.
brought
I learned
back
about it at
means,
school.
though, Alex? What do you think brought back means? Do you think it means we can just see it? We can just see it anyway, right?
It's just refracted. Makes everything look a bit flatter.
So brought back means we can't see it because it's not there. It's on the other side of the curve. So it's being,
it's like
quote,
when-
brought back by refraction because it isn't there. It's a 650-foot hologram.
You know, like when you put your toothbrush in a water or something, and then like the toothbrush is like all big and stupid. It's not like there, but it is there, but it's not there. Do you know what I mean? Like, isn't that refraction? I don't know. This is what I learned at school.
Yes, that's right, Alex. The toothbrush that you see isn't necessarily the actual toothbrush.
Yeah.
It's an
Yeah,
optical
exactly.
representation of something that isn't actually in the position you think it is. Like this lighthouse. It's a 650-foot
It's like a real world thing.
It's a 650-foot representation of something that isn't there because it's obscured by a 165-foot wall and 650 feet below your feet. It's a 650-foot hologram perfectly represented on the horizon. So
I mean,
you're
the
saying it's
650
just a
feet,
small
is
amount?
this-
No, it has to bend the light to bring something that's 650 feet below your feet up to sit on top of the horizon in perfect proportions.
I think you confuse yourself all the time. The
Not
650 feet
confused.
thing, because
You don't understand, Alex,
Yeah,
because
I
you're
mean,
slow.
it's just
That's been
obviously-
demonstrated on many
it is.
occasions.
Because it's not really 650-foot wall. It's not a wall for a start.
No, it's
You're
a
high up. It's just a drop. It's a
165-foot
drop
wall,
off.
Alex. Why are you now confusing me when I've said it many times on this show?
I think the
Go
point,
down to the
Why I'm
ball.
confusing
Go
you,
down.
man.
Scroll
Alex.
down to the
Alex.
actual ball.
Alex,
So you can see the.
I think what Nathan's in a roundabout way of saying is that there is an obstruction that covers the whole of the lighthouse.
Yeah.
And even if you can bring it back using refraction, ultimately, from our perspective, the light doesn't bend from behind the curve of the Earth. So from our perspective, that
Yeah.
makes you a fantasist. You believe
Yes.
stuff that is there that isn't actually there. So you think this is a mirage? So you remember that guy that said, what you're seeing here is a mirage. That's really what you're saying this is.
So we can't
not-
really see it. So we can't.
Yeah, no, I accept that. I accept that, but I also
So you accept that you
that's
see something,
real.
Alex. So you accept that you see something that is not in fact really there, correct?
Yeah, it's the same thing as the toothbrush, Nathan. When you're in the
Right.
water. It's
So finally, we've made a hologram-believing fantasist out of Alex.
we talked to that hologram, Nathan. Come on. I
Well
know you can't-
done, Alex. You're now a
We
true,
talked about the
fully
hologram. He
fledged
was-
hologram-believing fantasist rather than just a retard. Well done,
you
Alex.
look it up?
Only
Yeah,
took 140 shows.
Nathan, please let me say this on your show. A hologram, yeah, is 3D information encoded onto a 2D surface. Or like when you shine light, so like if you shine light through a 2D surface, like that's how they produce holograms. Or like the hologram you see on your credit card, or something like that. That's a hologram. Just
So
have
if
to
you
put
want,
that out
if you
there.
want to call
That one triggers me.
Alex, it's okay, my friend. Now we've got there,
Holographic
I'm quite
universe,
happy.
bro.
No longer triggered. Now we've got Alex to accept
thank you.
that it's basically looming, or what
Yeah,
else?
I've always accepted that.
It's a mirage. He doesn't like the word hologram. I don't give a shit what word you call it in your
I like
fantasy,
the word
Alex. You're
hologram.
still a fantasist, my friend. You believe you are seeing something that is not really there. You've reached the high levels of nickel and rumpus and what's the other guy, the Aussie guy, the bin man? What's his name? Paul Voigt.
Bin
You're
Man.
now at the same level as Paul
come
Voigt.
on, Paul's-
You are a fully paid up, fully fledged fantasist, my friend.
I wish
Well
someone
done,
would pay
Alex.
me.
You must be proud.
Alex, where do
So
I get
proud.
the check? Is it NASA? Yeah.
Alex, have you seen this this clip about this newsman telling everybody about Joshua Nowicki's video?
Oh yeah.
And the next words out of his mouth, you can't hear it because it doesn't come through on the speech. But what he
Okay.
says here, the next thing out of his mouth is, "What you see here
subtitles on.
is the mirage," which is essentially what you're saying. What we see here
Yeah.
is the mirage. You realise
Okay,
that,
maybe
right?
maybe it was because this I do remember this one when I was a flat earther and I looked into this. This one was a mirage, right? Because you can't see this all the time. You
Yeah, but
can't.
you're saying this is a mirage as well.
That's
Yeah,
what we're
but
saying
this
here,
is
Alex.
actually good evidence of
What,
mirage, right?
so
Because
Alex is
this
saying we
one-
can't see it all the time, so it's being
Yeah.
loomed
Yeah.
up 650 feet from beyond your view, Alex.
Well,
You
not
get
the
it now.
650
You
feet
get
from
it
beyond
now.
the-
you
You're a little bit.
shit.
You're still a bit confused with that one, Nathan, but I think you'll get there eventually. But this one's a good example, right? Because you can't always see this thing, right? So that proves that because if the Earth was
Proves
flat,
it's a
and you could see
hologram.
it because
Yeah,
it's there.
you tell us
No,
all
because,
about.
Nathan, you say
Now
you
you
see
now
it
you've
because it's
stepped up to the
there.
level of
Well, then how
rumpus,
come that
Alex.
thing's not
Now
always
you
there?
try and
Why does it
convince
get
us.
Alex?
Now
Alex, why
you
would
try
you
and
observe
convince
us?
me
Why does it
that it's a
always
hologram,
change?
my friend. Now
But
the
why is it
tables
always
have turned,
changing,
haven't
mate?
they, Alex?
Why
Now
are
it's not
observations
you
changing
telling
for
me
fractions
about
of
me
real?
being a hologram-believing fantasist because you finally
No, I
realised
think you are,
that
Nathan.
it's
Think of it this
you who is the hologram-believing fantasist. It's
Okay,
you
that's fine, you
who
made a
needs
point,
slightly
whatever.
looming non-standard refraction hyena to come and save your ass because you can't see the bloody thing.
love hyena.
It's
I'm
not
an
physically
honorary member of the
there.
hyena.
It's a geometric impossibility, Alex.
I'm
You
an
finally
honorary
got the
member
penny
of
to
hyenas,
drop.
bro. There's not many
I
of them.
do love stupid people.
Well, I'm an honorary member of the hyenas. But Nathan, if refraction and stuff's not real, so when we make these observations, why don't you make them again and again and again, and then see if they're the same
We have.
every time? If it's
Ranty's
just there,
gone back.
if you
We
see
have.
it-
We
Hang
have.
on, can I
We
finish?
have. We
Can I
have.
finish?
We've gone back. Ranty's made
No.
the same observation of the same
What, the
lighthouse in the same
spots, and it's
position on a
exactly the
different
same.
day.
And
Why
have you
aren't you
laid them
listening
over
to
and
me?
shown that?
Why aren't you
Or have you
listening
done
to
one
me?
over the day? Why don't you
Why
do a time
aren't you
lapse over the
listening
day
to
and see
me?
if it
Why
moves?
haven't you just acknowledged that I've just confirmed that they have gone back and taken the exact
Yeah, I
same
said, where is
observation?
it? Where can we see it?
Oh yeah, I can show it. Would you like to see it?
Would you like to see the
let's-
same exact
let's watch it.
observation on a different
Because
day, Alex?
and while he's bringing it up, the reason I make the point is because a lot of these observations, like the one you just pulled up, can't be demonstrated at certain, like they change. You know, they're not always the same. So if we're seeing it because it's there, why is it changing? It's because the hologram, Nathan. The hologram's going crazy, bro. It's a glitch in the
Okay,
matrix.
what about some nighttime observations? Would they satisfy you?
No.
Well, no, I just want to see them laid over again and again to see if you're seeing the exact same thing every time.
All right, this is one that's laid over again and again. It's a stacked
Right.
image that's been done 21 or 25 images that have been put on top of each other to make it a
Right.
little bit more clear.
But you need to flick through them, yeah. Show me laying them on because that's just stacked up, then, isn't it?
So,
Right,
Alex,
this is a stacked image of 20
this is
plus
what you've
images.
asked
Okay,
for.
right.
Yeah,
Can it be
show-
done on a
show them
different
going
day?
on, like in a video,
Here
like
it is on a
boom,
different
boom,
day, Alex.
No, I can't show the stacking process because I
That's what I
didn't do
need to
it.
see. Well, that's
That's
but
all
that's
right.
what you need to show to prove
Well, we
it,
can show
isn't it?
you a
Because you need to
single.
stack
No,
we can,
no,
will
no.
a single still
Right.
do you, Alex? A single still from the stack, a single photograph. Will
Okay,
that be
yeah,
acceptable?
yeah. Okay, so do you know why I would say, like, just from looking at that, it's a problem? Why does the lighthouse seem to go all the way to the horizon?
different
No.
levels of refraction on the
Well,
day.
this is the point now that I'm making, Riley.
Well,
Thank
the point is, it's not like dropping behind the curve and coming back up again, dropping behind the curve,
Well,
coming back
if
up again.
it's there
It's still
because
there.
Yeah, but if it's there because it's there, why are we seeing it different places?
We're
Why
not.
is it changing?
We're
Well, we
not.
are.
It's
Different
not
Different
in
levels
a
of
different
refraction.
place. It's in exactly the same place on a different day in different conditions, Alex.
Yes, that's the point. The different conditions make a difference to how we observe it. So
Yeah, but
therefore,
Alex-
it isn't just there because it's there. The conditions make a difference to how we observe it.
Alex, would you agree though that we see that like there's the lighthouse itself, and the building that's to the right would be this building that's to the right, and we see that in the image. So we are seeing the lighthouse, and we are seeing now this has been stacked. Ranty's got all the originals that were sent over to the bloke that stacked it, and we've had it stacked with 25, 21 images, and that's the level of the improved level of visibility that we see on the image. We can see all the fields, we can see the houses, but that lighthouse is an issue because it should be gone behind the curve of the earth, but we still see it. So if you're arguing that this is mirage, it means that the rest of the mountain itself is also mirage because it has to be all brought up by the distance of the lighthouse. So really, Snæfell Pike or whatever this peak is here isn't really there. It's actually here instead, and then it's mirrored underneath.
Yeah, but it's not a uniform refraction going upwards, is it?
Yeah, it is.
Well, it would have
less
to,
and
wouldn't
less.
it?
The picture
'cause the
presents
atmosphere
itself,
changes,
Alex,
doesn't it,
as a
as it gets higher?
perfect representation. Absolutely perfect. It's a 650-foot hologram that is perfectly represented in scale. So anyway, just going to do a quick link because we have approximately half an hour left on this live stream. So I hope you're all enjoying the debate thus far. If you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show while it's live, and a link in the info box once the video has rendered. But if you'd like to join the panel, please mute the page you are currently watching, then click the link in the info box to join the discussion and express your views on the shape of the Earth. There are a couple of rules. Please don't swear. If you do, you'll be ejected, and if you are, please don't try to join the show using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show, as sharing the show increases the live audience, which in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you are new to the channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. There is approximately 30 minutes left on this live stream.
So I'm sure people want me to ask you to clear this up, Riley. So didn't you say you threw a 66-foot tape measure over the cliff, and there was like room for it to hit the bottom, but then later you threw like over 100-foot tape measure to the bottom. You measure 111 foot
locations.
Oh, okay.
The 66-foot one was halfway up, where he did his observation to the side of the caravan. That definitely had tape left over. And the highest point, the highest observation point, the longer tape was able to reach the bottom, but the shorter one wasn't.
Right. So, but the one you took the observation from was the higher one, wasn't it?
I didn't take the observation.
Oh, but the one that Riley took the observation is the higher point, wasn't it?
Correct.
Yeah, okay.
But Nathan said to me that I'll probably still see that lighthouse at the lower observation. And the next time I go up there, if the weather's good enough, that's exactly what I'm going to try and do. And I agree with him. Based on what we can see so far, we will probably see the lighthouse from the lower elevation. That would throw a spanner in the works because we should never see, well, it's even more of the lighthouse shouldn't be seen even more from the lower observation, but I reckon we'll see it on a clear day. So what would your position be from the 35-foot elevation that turned out to be?
Yeah, well, it'd be interesting actually. You could they could do one of the higher, do one from that location, then do like one from the beach, and then compare them like roughly the same time.
Now, I've got a hypothetical question for you, and it is only hypothetical, meaning that it's not based on real world, it's based on science, right? What would your position be, your position, without consultation with any of the ballers? What would your position be if, you know, where the Rumpus took his observations from that triangle car park bit at the bottom? What would your position be if the lighthouse could be seen flashing at night time from that car park?
What from?
Well,
I don't know really, because I just don't think it's that much difference, to be honest.
Okay, fair enough.
But so I don't know well enough. But it'd be interesting. I think you should do it. Loads of people in the chat, Riley, are asking you questions about your tape measure. So I don't really follow this that closely, but they're saying, Ranty said in the comment last night that Riley still claims that the composite is from the lower observation. So is that true? Or you don't claim that? Or Ranty said that anyway.
From what I understand, it's to the side of the caravans and further back. That's where I think he did the composite from. I might be wrong. I could be wrong. Maybe Anthony could clear that up.
I think he just said no, he did it from the higher one, so got that one cleared up.
I know we had three. I know we had 3 videos, and when you had the oil rig that was to the side of the head point, you could see that there was an angular change on all 3 of the videos, showing that he moved further left or higher up the cliff. Right. I believe it was the second video that the composite was taken from. I might be wrong. If that's the case, then if it was the second video, then that wasn't actually at the very top, because there was a higher point on a 3rd video that he released that showed that the rig itself was further, was nearer to the actual head, proving that it'd gone further up the cliff or further to the left. Right. Again, you're going to have to ask Anthony again which video it was that he gave me for the composite.
Wait a minute. So
I'm here. I'm on the phone, but I missed the question. What was the question?
Ranty doesn't know after all this time. Are you kidding me?
What?
What a joke.
What?
I don't know what bloody video he did, where it was from. Are you kidding me?
That's a recorded message.
Yeah, it is. It must be.
It's not a recorded message, you idiots.
It's a very advanced recorded message.
It's an AI.
So is this Chris? The Chris that was in the chat saying he was going to destroy the show?
Does sound a bit like Chris.
Yeah, I think so. It is, yes.
Yeah. Probably not a good idea to tell people in the chat that you're going to destroy my show. Idiot.
Alex, what was the question that you were talking about? I was on the phone when you started talking.
So just about where, you know, the main composite we're looking at, what observer height? I think the best way is like what is was it your highest observer point, or was it your low one?
Where the composite was taken from was the highest observer height.
Right. Okay.
So it was so it was video 3 then. The furthest point on the left. You know when you had the 3 oil rigs? Well, the 3 clips that showed the oil rig going to the left. So it narrowed the point between the head. Are you telling me that the composite was taken from the furthest to the left, so the highest point? Anthony?
Is that, sorry, no, I don't know what you're asking me there. The answer to the question, where was the picture taken, the video taken, it was taken from the top.
Right, okay, fair enough.
I'm sorry, Ranty, I didn't understand what your question was then.
Right, there was 3 videos released, and on each individual one, you could tell that you'd moved position. You could tell because of the oil rig and the topography of the land, so you knew that you'd moved. I thought it was the second video that you released, so the one in the middle, where you did the composite from.
Yeah, I get you. No, it was taken from the top.
Right, okay, fair enough.
Can I have like 5 minutes to share some stuff I've been looking up today?
I'd love to.
Go on, please.
Okay, so we all know that the ball earth lie starts in education. And I looked up this German philosopher named Johann Fichte, who was instrumental in starting the education reform known as the Prussian education system, which the United States adopted. And, you know, that's where we get the term kindergarten, which means a child's garden. And, you know, you think the term child's garden, you hear some of these quotes, it's kind of disturbing. So this Fichte guy, he said, education should aim at destroying free will so that after pupils are thus schooled, they will be incapable throughout the rest of their lives of thinking or acting otherwise than their schoolmasters would have wished. And he also said, the schools must fashion the person and fashion him in such a way that he simply cannot will otherwise than what you wish him to will. And this is the education system we're still using today. I think they're talking about reforming it. They started talking about reforming it in like 2010, so it might be changing soon, but it's based on like this factory model of education. And even today, there's a Professor Benjamin Bloom, who's known as the father of outcome-based education, and he wrote The Taxonomy of Education, which all teachers is like required reading. And in this, and I'm not sure where this quote came from. I think it's from that book. I could be wrong. But Benjamin Bloom is quoted saying, "The purpose of education and the schools is to change the thoughts, feelings, and actions of students. A large part of what we call good teaching is the teacher's ability to attain effective objectives through challenging the students' fixed beliefs and getting them to discuss issues." So they're telling us right there that they're using education to challenge students' fixed beliefs. You know, so I think flat earthers might find that interesting. Anyways, I'm done.
Cheers for that, Matt.
Cool.
Awesome.
Yeah, I had something to present again. If you want to present me in a moment. Get on to that. Put that out there. Oh. You tell me when I'm presenting, Nate.
So I'm fiddling around with it because it's just incredibly slow today.
Okay, no worries.
It should be up now. I'll just check. Can you tell me in chat if you can see your anti-screen, please? Should be able to. Chat dies.
Yeah.
I'm waiting for it to come on.
You have to click on his screen locally if you're in the Hangout.
No, I was waiting for it's on. I was
It's
waiting
on.
for the. I was
Right,
watching
okay.
the thingy chat. Go on.
Yeah, go ahead, Ranty.
Yeah, I'm going to go back to this observation that I did when I went to Barrow looking at Blackpool, because I feel that at night time you do see a lot clearer and a lot further. So as much as the observations at the Isle of Man have been pretty decent, especially seeing the lighthouse and stuff, I feel that if we was able to get some lights on the actual land itself, we'd see a lot further and a lot lower. For instance, like these parts of the illuminations here, they're sitting around about 16 to 18 feet above sea level at this time. And the distance there is 19 miles. And when you're looking at this and you're looking across the sea and you're seeing this entire landscape lit up like a Christmas tree, you realize that the Earth is flat, because this is impossible on a ball Earth. You shouldn't see these illuminations. I mean, I can show you on a video where I was. Here's the tripod. You'll see the tripod in a second, and you'll see the water. I mean, I've stuck the tripod in the water. Hopefully you'll see it. There we go. You can just make out the water's edge there. And you'll see my tripod sitting around about 3 feet. And this is where I took the observation from. There's my camera, my P900. And I think that I can show you some, for instance, on here. We have the Metropole, which is here. And we have the Cenotaph, which is probably, I think it's about 80 feet or so in height. This Cenotaph, it's a tall, thin building. And you've obviously got the piers and Blackpool Tower. But you can see these on the building. You can see the Cenotaph is here. And you can see the Metropole to the side of it. Then you see the tower. Then you've got the piers coming out, so you can't see them anymore. Which is here. You've got the piers that are blocking off the illuminations. The only part you do get is a small break in the piers here, which allows you to see the illuminations here. 18 miles away. It should be beyond 140 feet of curve. So at night time, you do see much further. There's the big one on the right. And then we do have the mirror ball further along somewhere. Maybe not on this video, it's on a different video, on a different image. However, yeah, I think nighttime photography is very much underrated, especially when you've got Blackpool, which is so easy to pick out individual things that are seen in the evidence. And I can show you. We're going to Google Maps. There's the distance, 17.9 miles. Curvature calcs, refracted hidden, 141 feet. So we shouldn't see any of this. And of course, if I go into Google, I'll put my little man here, and you can see the illuminations and how they look. Where's my little man? Just stick him here. And there's the illuminations sitting here, and there's the sea just to the left here. There's the illuminations that we're seeing. And it should be 140 feet. I mean, these buildings aren't 140 feet. These buildings are about 65 feet tall. So you shouldn't see any of this. None of this should be seen.
Before we end the show, like, I don't know when you're in the show, just it might be now. Do you really think I'm an agent, Nathan? I'm a paid agent? Because you're like messaging Riley saying I'm an agent or something on Skype. I only mention it because he was screen sharing it. Like, just wondering.
I mean, I feel like I'm paranoid. I think there's a lot of agents in this community,
You're
and
right.
I can't really prove it, except for Mark Sargent. But yeah,
Do you think I'm an agent, P. Mars? Do you think I'm?
I don't.
That would
but
make me the best agent, though, wouldn't it?
I do.
It would.
I think Alex
Yeah.
is an agent.
Secret agent, man.
I think Tim Osman is an agent,
You reckon?
and maybe Gem Panda.
Jem's an agent.
No, Jem
That's
gets
all
far
those
too
sirens
triggered
are
to be an
going off in the
agent.
background. This is agent sirens.
I'm a bit suspicious of Twitwit. She admitted to being part of the military.
So Twit's an agent.
I don't know. I'm suspicious. I'm suspicious of a lot of people.
I think like people are getting. It's a it's a paranoid sort of community, isn't it? Really, it's kind of to be expected, I guess. I promise you, I'm not an agent though.
I mean, it's hard to know, like, if someone's an agent, if they're like a willing dupe. I don't know. It's hard to say. Like, and some people just want to be a part of something. I don't know. It's hard to say, and it's hard to prove it. But I think
Quite
it's
open
safe.
about my life.
It'd be safe just to not trust anyone and get too close to anyone in the flat Earth community, because there's definitely a lot of spooks running around here.
Yeah, I've been a little less open, to be honest, because I think, well, and it's a lot of crazy people, and you just don't really know. You don't want to go, give too much about yourself away. So it's probably best to.
Yep. And after reading all this stuff about education and indoctrination, I think you can't even really trust yourself. You go into school with a fixed belief that maybe the Earth is flat, you to the point where you can't even question what the schoolmasters have taught you. That's a fact.
Well, I've always said it's like healthy to question what you believe. I just think it's gone a bit far in the flat Earth. Gone a little bit too far.
Hey, Alex.
There's lack of credible evidence to support the ball. That's just the simple facts of it. I mean, prove gravity. Show me curving water. You can't do it.
We've been arguing about
the only thing we have is some images from space, from apparently NASA, that show continents that are 3 times larger at one point than another. It's just ridiculous. That's all we have.
What about the sunsets?
Can I ask a quick question to Alex? In the debate, I know you've been keeping up with this. We point out that when you look left and right, you see no curvature, and it's claimed that you can't see any even if you're at cruising altitude. But would you agree with that you shouldn't see any curve going left and right in just your average photo?
Yeah, I mean, not detectable. Yeah, by your eye.
Can you answer me this then? Why has Metabunk just updated their curve calcs to have an advanced tab that accounts for seeing left and right curvature in photographs? Why is that?
Because there is left and right curvature, you just can't detect it with your eye.
Why are they calculating it then? Because if you can calculate it...
Because it is there. Because obviously it is there. There is curvature.
So you're saying you can detect it and it is there. You can see left and right curvature.
Yeah. I just meant without your eye. Yeah, you can detect it, just not with your eye.
So you can. So we should see some images produced from here.
With your eye, you can't see it.
Sorry, so we should see some produced images from here forward showing a curve on the horizon, correct?
I mean, I guess if you got really accurate and the camera was, you know, had enough pixels or whatever, mega, I guess you could do it, maybe, with enough resolution.
All right, it's interesting. It's just this is something that we pointed out during the debates, that there's no left and right curve being measured, and Metabunks just literally updated their calculator to account for this and give you a
Yeah,
way
but
of measuring.
how much is it? It's tiny, isn't it? It's not perceivable by
measurable
eye. Like
according to
It's got to
Metabunks.
be the same. It's got to be the same as what you're looking at forward, straight ahead. So the curvature calcs, when we're looking at something 30 miles away and the drop is, say, 300 feet, then you should see that same 300 feet left to right if you're looking over a 30-mile span.
Well, I took a picture from
are you looking over a 30 miles?
I took a picture from a plane, and you can't really see the left to right curvature until you like take a line, you know, like in paint, and put a straight line over the horizon, and then you can see a little bit of curve.
At 30,000 feet, P.
It's the same as the high altitude balloon footage where they claim it's flat, but if you watch a rectilinear and then you put a line across it, you can see the curve.
That's right. Okay, Alex, I want to ask you a question. Given that you said that the lighthouse must be a mirage, right? That's your position, yeah?
Yeah. Okay. Yeah, I can do that.
So, just hypothesize with me. If we were both in a submarine and we were both looking up a periscope, and we saw two boats, one was close to us, one was miles away. Me and you, I would say, I can see both the boats, therefore I can find my torpedo at either, and I'll hit either. You would say, hang on a second, one of them's a refraction, it's mirage. Don't fire at the long one, it's behind the curve of the Earth, and you're not really seeing it, right?
The torpedo? Oh, right, so we're firing a missile at boats.
Imagine that we're both on a submarine, and we're both looking through the periscope, and we see two boats. One is clearly close to us, and the other one is in the distance. I would say that both the boats are real. You would say the close one is obviously real, but the further one, nah, that's behind the curve of the Earth, right?
It could be, yeah.
Really?
Well,
how would you then
you know, like when you see ghost ships mirage into the sky, you wouldn't shoot at that one, would you?
So it's a mirage.
Well, that's clearly Fatima.
Yeah. Mirages happen, right? They do happen.
Nate, would you mind presenting my screen?
You are.
Yeah, I'm seeing it. Yeah.
You've seen it, right? This is Taboo Conspiracy's latest video. It's only 1 minute 36 seconds long, and it does come with sound. And I'd respectfully ask everybody on the panel to let the whole video play. It's only 1:36, okay? Listen to the conversation. This would be me and Alex in the submarine, and this is what we would be discussing.
Times they are changing.
No. The one on the left has to be an illusion. But I think we can shoot the boat on the right. The curvature chart says it's okay.
Yep, there's a Kitty Hawk.
Certainly not that one. That's a refracted image of a boat that's hidden below 50 feet of water. Stupid flat earthers actually think that's a boat there.
We're not gonna be able to see
No, the same with that one. Don't shoot, that's a mirage.
Destroyer, and then
ooh, that's a tough one.
That's
maybe half refraction, half real. So aim for the top half of the boat.
Okay. Let's just zoom out.
Not that one. That's refraction. There's no boat there. You're aiming at a wall of water.
We should see Seawolf coming up pretty soon, right?
Yes. Finally, the curvature chart says that one is okay to shoot.
Just keep cycling through.
Absolutely not. It's actually hidden behind something like 40 feet of water.
Yeah, there's a scope. It's bomb.
Why in the hell did we even install a periscope? It's not like it's useful for any boat beyond a few miles.
Well, if it's there because it's there, you should be able to shoot it, shouldn't you? But you're going to miss.
Yeah.
Because it's not there.
So I just want to be.
It's a hologram.
I just want to acknowledge Taboo Conspiracy for that video. It's his most recent video on his channel. Please go and check, subscribe, like. The guy's doing some really cool work at the moment, and I'm sure he won't mind us discussing it. The point is, there must be some line where the submarine guy would be able to decide whether it was a real ship or a mirage, right? does that happen in real world, or do they just point
Yeah,
it
because
and
like
shoot?
if they could just aim at it and shoot it, they would, wouldn't they? But they have to like use
Yeah,
whatever
they do.
targeting.
They
or
do,
whatever
Alex.
GPS
We
things.
do have wars. People do get shot. Boats do
Yeah,
have
yeah, but they
torpedoes.
don't- yeah, so how
they
do you think they
target
target
stuff.
things that far away?
They
They don't do it
never,
with
they
the
never
scope.
do what he's done. That was farcical. They never say no, it's
Yeah.
not there because there's a curve in
No,
the way.
I know, but
They don't have these conversations about imaginary walls that are accounted
no,
for
they
with
just don't target.
mathematics.
Okay, doesn't matter.
Alex, would you
should
agree
go
though
look it up,
that
though, 'cause, like I heard about this, like people were talking about some guy who's working on these ships, how they target things far away. They don't just look at
yeah,
it.
and they
down
don't
scope.
take into account any
But
curvature.
they'd be able
yeah.
to, wouldn't they? If it was there because it's there, like you guys claim, they should be able to shoot at it. But it's
Right.
not. 'cause
So
they
what do you
miss.
think the conversation would be if me and you were on the submarine and I was looking at a ship and I would say, right, there's the coordinates, fire, and you go, whoa, wait, it's a mirage. It's not really a boat.
Well,
and
you
and
hope
would-
that Arm
I'd
isn't
look at
that
you.
disorganized that they don't know how to operate their
No, but what I'm saying,
Okay,
Alex,
let's
is do you
let's
agree
say
that
let's
that
put it
conversation
another way
does
then.
or does
If
not
you're
take
on
place?
if you're on the boat and you're under attack and you can see the boat coming towards you, at what point do you fire?
Yeah,
Well, maybe when it's
exactly.
not all blurry on the horizon.
Yeah, but is
Yeah,
it blurry on the
glowbursters will
horizon
be
because
dead.
it's there,
or like
is it
floating
blurry
in
on
the
the horizon
skies.
because
Don't
it's
shoot-
refraction?
Don't shoot that one.
You know, at what point do you say that's no longer refraction? Would you refer back to the curvature chart, or would you take the chance?
They do
You're
it
gonna get blown
GPS
out
and
of the water.
satellites and stuff, man. Come on, you know this.
So that's basically the point here, Alex, that there reaches a point. Hi, Arwin, is that really you?
Yes, that's really me.
There reaches a point, Alex, where you have to decide arbitrarily whether or not you have a straight line of sight to stuff. And according to the Metabunk maths, you can have a straight line of sight, but if it happens to be something that should be obscured by curve, then suddenly refraction kicks in.
But if you shoot it, will you hit it?
Yes, Alex, they do definitely
won't.
target
You
ships
won't hit
that are
it.
beyond
You
the
won't hit it, that's
horizon
the
on a
point.
globe. Why are you talking over me? You've just asked a question, now I'm answering you.
Sorry.
Yes, they definitely do shoot their guns, Alex. That definitely happens.
That wasn't the question I asked, though, was it?
Yeah, they definitely sink ships, Alex. People
Yeah,
definitely
but was that
do
the question
die.
I asked? Though? You want to answer my question? Answer it. If they
Yeah,
hit
go
that
on then.
mirage
Can I-
thing on the thing,
Alex,
is it going
ask
to
your
hit, or will the
question
bullet
again, go
go
on.
through it? Because it's a mirage.
No, it will sink the ship because it's not a mirage, Alex. That's the point. We do have straight lines of sight. We do see things that are there. The mathematics
Really?
that goes along with an imaginary wall blocking them is nonsense. You believe in
So-
it,
so-
even though
so
it's
if I wanna
no
nonsense.
shoot- if
purpose
I wanna
for
shoot
binoculars if that was the case.
If I want to shoot the shoreline of your lighthouse, how am I going to do that? Because
You
there's
can't
like
see
stuff
it.
in the way.
You can't see things, so you don't shoot things you don't see. But what about the stuff we do see,
Yeah,
like
that's
the
the point. Why don't I see
What
it?
about the stuff we do see, Alex, like the lighthouse and the ships on the horizon?
I wonder what
Can we
happened
shoot
if there's
those?
refraction and you shot at the
Let's
lighthouse.
not worry
Are you
about
gonna hit
things
where
we
you think
don't
you're
see,
gonna hit?
like light bulbs that aren't on. Let's worry about the stuff we do see and about the stuff we can shoot because we have a direct line of sight with it. According to you, we couldn't shoot this lighthouse if we had a gun because it's not really there. It's not there. It's a geometric
Yeah.
impossibility. Remember, Alex,
Yeah,
you
we should
conceded
try it.
this.
You
You
should
hologram
try it.
believing
No, don't try it.
fantasies.
I'm not encouraging you to shoot.
Technically,
Stop
according
Spider-Man.
to globe lore, it would be possible if gravity would bend the bullet's path over the curve.
Well, yeah, that's another issue. I mean, let's think about Spurs' laser thing, right? You know, he talks about is your laser going to go off to space? And we say, yeah, it is going to go off into space.
Can I just say that Slice Barcane also thinks that periscope operators actually have the curvature argument when lining up torpedoes? Alex, you're not on your own. There's another fantasist in amongst us. Slice, shout out.
So with that, I'm going to say first and foremost, a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate as my kids right on cue jumps on me during my outro. Also a massive thank you to all of the debating panel for making this debate possible. If you've not done so already, be sure to like, comment, share and subscribe. I've been Nathan Oakley and I'll see you all in the next video.